Sir, should we start or should we wait for
Yeah. I think,
I think you should start now, or
okay.
how much should we
yeah,
take?
Okay, okay, sir. Okay, we should
I
start.
think you should start.
Okay. Good afternoon, all. Welcome to the SCT SGIE monthly lecture series. Today we have with us Dr. Rahul Dixit. Before handovering this platform to Rahul Dixit, let me give a brief introduction about Dr. Rahul Dixit. Dr. Rahul Dixit got his bachelor degree from University of Delhi in 2015. Then he got his master and PhD degree both from IIT Roorkee. Now he's working as an assistant professor at University of Delhi. Recently has published couple of papers from Kumaon Himalaya and hope to learn more about these papers. With this brief introduction, now I'll hand over this platform to Rahul Dixit. Over to you, Rahul.
Thank you, sir. So, first of all, I would like to thank the SGTSGI for giving me this opportunity to deliver my PhD work here. This is on that, and I would like to thank Santanu sir and Arun sir for inviting me here. Am I audible to everyone?
Yes, 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 yes,
Yeah,
Rahul.
you are audible.
Yeah, yes, Rahul. Yeah, yeah.
Okay, okay. So today the topic of my presentation would be the structural anatomy on the protolith characteristics of the Munshiari and Vakrata, which we also call the main central thrust in the Garhwal Himalaya. So, as we know, starting with the introduction of the Himalayas, so we all are aware of the this excellent mountain chain that is the Himalaya, which is formed because of the continent, which is a consequence of continent-continent collision that took place between the Indian and the Asian plate somewhere between 61 to 57 MA, and because of this collision, approximate 2,500 kilometer long northwest southeast trending mountain chain that the Himalayan origin was formed, and it consists because of as a result of this collision. This mountain belt consists of several regional scale fault systems, and these fault systems basically divide several lithotectonic stratigraphic units from each other. And if we start from the southern, then we have the in the south the main frontal thrust, and if we move towards the north, then this main frontal thrust separates the Indo-Gangetic plains from the Shivaliks. Then we have the main boundary thrust, which separates the Lesser Himalaya from the Greater Himalayas. And then uh, uh, further to north of the Greater Himalayas, we have the main central thrust, which separates the Lesser Himalaya from the Greater Himalaya. And then we have the South Tibet Detachment System, which separates the Greater Himalayas from the overlying Tethian Himalayas. So this work is mainly focused in the Garhwal Kumaon Himalayas. So here in the Garhwal Kumaon Himalayas, if we see, starting from the south, again we have the same set of fault systems which basically divide the entire Garhwal Kumaon region into several lithostratigraphic units. Starting from south, we have the main frontal thrust, then we have the main boundary thrust, and then north of the main boundary thrust, we have the lesser Himalayan units. And this lesser Himalayan sequence within the Garhwal Kumaon Himalayas is basically divided into two parts. That is the outer lesser Himalayas, which consist of the several formations like the Chakrata group or the Jonsar group, which are Neoproterozoic to Paleozoic in age. Then we have then they are above north of them. We have the inner lesser Himalayas as we move towards the hinterland side, and usually we have these Ramgarh Munshari group or the Berina group. They are the part of the inner lesser Himalayas, which are essentially the Paleoproterozoic in ages. Then to the north, further north, we have the Vakrta thrust or the main central thrust. The main central thrust is known by the name of Vakrta thrust in the Garhwal Kumaon Himalayas. And then this main central thrust divides the inner lesser Himalaya, separates it from the overlying greater Himalayan sequences, which further consist of several formations. And essentially, the rocks in the greater Himalayan sequences are Neoproterozoic to Ordovician in age, and they are further included by several Paleozoic or Cenozoic granite or orogranite. Then we have the South present in the Himalaya, especially in the Garhwal Kumaon Himalaya. The work that I have mainly focused is basically it is mainly related to the main central thrust, and why it is important to talk about this thrust system that we'll see in the further slides. So to start with the main central thrust, it is basically a four-length propagating Cenozoic high strain shear zone that emplaces the greater Himalayan sequences on top of the lesser Himalayan sequences. So we mainly focused on the three river valleys in the Garhwal Himalayas. That is, one here is the Alaknanda Valley. Then we focused on the Dhauliganga Valley, and the third one that we focused on the Bhagirathi Valley. In all these three valleys, the main central thrust, its immediate hanging wall and footwall are excellently exposed, and there is an accessible approach in all these three valleys. So starting with the history of the main central thrust, so the journey of the history of the main central thrust starts with the work by the Hyman Genser in 1939 when they coined this term main central thrust MCT mass, and they said that it represents a single discrete thrust plane, and basically that work was mainly carried out along the Kali River valleys in Kumaon Himalaya. Then after that, there was a major work that was given by Waldia 1979 and 80, and he further recognized two more thrusts in the same Garhwal region, and the lower one, which was in the southern side, that was the Munshari thrust, and towards the north, he recognized another thrust, named it as the Vakrta thrust. And then based on the metamorphic isograde, sudden change in the metamorphic isograde and the deformation style, he recognized the Vakrta thrust as the main central thrust within the Garhwal Kumaon Himalaya. Now, this particular this particular thing of assigning the Vakrta thrust as the main central thrust has been further supported by the several recent works also, like the Ahmad and et al. 2000, and Mukherjee and others in 2019, through their isotopic and geochronological advancements. They reported the contrast ages and isotopic ratios across the Vakrta thrust, and they also supported the idea of the Waldia that Vakrta thrust should represent the main central thrust. But there has been another group of people that they have recognized the Munshari thrust on the other hand as the main central thrust, and coincidentally, the location of the Munshari thrust coincides with the location of the main central thrust of the Hyman Genser. So, because of all this further advancement into the journey of the Munshari thrust and the Vakrta thrust, there has been a lot of confusion to assign the main central thrust to which of these two thrusts. But in this study, because of the presence evidences of the isotopic studies and the geochronological studies, we have adopted the assumption, we have assumed that Vakrta thrust represents the main central thrust. Now, the point arises that why this thrust or the main central thrust or the Vakrta thrust, which we are calling in the Garhwal and the Kumaon Himalayas, why it is a debatable shear zone. So there are several reasons, like if you see, so there are these reasons regarding the structural complexity of the Himalayan because of the multiple deformation and metamorphic events that have occurred. because of the poor stratigraphic and protolith characteristics of the hanging wall and footwall rocks that are present there. So it's many a times it becomes difficult to identify and separate the footwall lesser Himalayan rocks from the hanging wall greater Himalayan rocks. And because uh, because of the multiplicity of the nomenclature in the assigning a particular thrust a name, so several workers they work in different valleys all along the Himalayas, right from the Pakistan to the Arunachal Himalaya, and the same thrust having the similar characteristics is named by different nomenclature in different values, and this ultimately creates a confusion to assign a particular thrust as the main central thrust. So, because of all these complexities in identification criteria for this particular thrust, there have been a set of definitions have been arised to define the main central thrust, starting from a single discrete thrust plane to several kilometers thick ductile shear zone. And then Martin 2017 broadly categorized several and the third one was the protolith boundary structural definition. So based on the available metamorphic evidences, structural evidences, based on the available geochronological and isotropic evidences, we have categorized all the definitions into three broad categories. And but when we see that because of these several complexities, several workers use different identification criteria to identify the main central thrust. And these identification criteria, some of these criteria are the lithological contrast across the thrust, metamorphic isobgrade across the thrust, or the isotopic and geochronological characters. But many or maximum of these identification criteria that the workers have used in the past, Searle and others 2008, they argue that many of these criteria do lack the detailed structural data, or they do not involve the detailed structural data that is basically required to identify any fault or shear zone in the field. And most of these criteria that are being used to identify the MCT, they lack the shear zone framework, which is the primarily requirement to identify any shear zone framework, because any shear zone, because of all these complexities that are present in the region. So several difficulties arises in locating the main central thrust, and there are several ambiguities in locating the main central thrust. And because of all these ambiguities, a poor comparison correlation of maps, cross section, and tectonic models is present. So this is one aspect that we need to that we'll be discussing in this particular presentation. And then there is another aspect that is regarding the age of the movement along the main central thrust. So when we talk about the movement, when the first movement along the main central thrust initiated, so the reported ages vary somewhere between 23 to 11 million years. That is the activation age of the main central thrust all along the Himalayan region. And then we have another age from 9 to 6 million years. These are the reactivation ages that have been given. However, there are very few scarce records of the early Paleozoic tectonism affecting the main central thrust movement. Like the Desailles and the Garrels, they have reported some sort of the effect of the early Paleozoic tectonism that have possibly affected the movement along the main central thrust. And according to them, there is also a possibility that the total amount of displacement that is present that has occurred along the main central thrust, it may have it may have a significant amount of pre-Cenozoic displacement along it. But since the results from this particular regarding this particular aspect of the early Paleozoic tectonisms are not yet finalized in my study, so I will not discussing much about this particular aspect. So basically, we'll be focusing mainly on the structural aspect of the main central thrust. So overall, the objective of this presentation is to understand and study the structural anatomy, deformation style, and tectonic evolution of the Munsiari and the Vakrita, which is the main central thrust zone in the shear zone framework. We need to also we'll be doing the check on the vulnerability of the metamorphic isograde criteria to delineate the Vakrita or main central thrust, which this particular criteria was originally given by Waldia. And since the Waldia, this is one of the most widely used criteria that have been used to identify or locate the Vakrita thrust in the Garhwal, especially in the Garhwal Kumaon region, because of the sudden change in the metamorphic isograde. So we'll do a check on this particular criteria also. And the third one is to constrain the true depositional age of the Berinac formation. And basically we have focused on the Munshari depositional history through that will be achieved through the third objective. So when we talk about the lithotectonic sequence of in the study area, so as you can see, starting from the south in the inner lesser Himalayas, and it goes up to the South Tibetan detachment and the Tethyan Himalayan sequences. So this lithostratigraphy is from the Alaknanda Dhauliganga Valley and the Bhagirathi valleys. So right from the inner lesser Himalaya, it consists of the two major groups here, that is the Berina group in the south, and then we have the Munchiari group in the north, and both are separated by the Munchiari thrust, and both are essentially Paleoproterozoic in age, and where the Berina group is consists of the penny-contemporaneous quartzite metavolcanic chloride cyst intercalations. Then we have the Munchiari group rocks, which usually consist of the organ mylonites, orthogneisses, and sheared gneisses. And then above the Munchiari group, further north, we have the Vakrita or the main central thrust. And on the hanging wall side of the Vakrita or the main central, we have the greater Himalayan rocks, which are essentially Neoproterozoic in ages, and they are further divided into three main formations in the Alaknanda Valley, that is the Joshimath formation, then we have the Surai Thota, and towards the STDS, that is the South Tibetan Detachment System, we have the Bhapkund formation. So all the rocks that are present within the Vakrita group, they are mostly Neoproterozoic in ages, and they are further intruded by the Paleozoic to Cenozoic granitoids. So we can see that there is a sharp contrast along the across the Vakrita thrust. The footwall rocks are mainly Paleoproterozoic, whereas the hanging wall rocks are mainly the Neoproterozoic in age. So when we talk about the kind of methodology that we have adopted to understand or to study the both shear zones in our study area, so we adopted the shear zone framework approach using the strain-induced core and damage zone geometry. So using this particular shear zone framework approach, we try to map and identify the fault cores or the shear zone cores and their associated damage zone within the area. And for this, we of course we adopted the field-based observation. We did the grain statistical parameter and parameters, and then we also performed the quantitative strain estimation using the Fry method, and we also measured some SC fabric dihedral angle variation across the given shear zone. So within the shear zone framework, we know that there is a if hello.
Hello.
Should I continue?
Yes, yes, please go ahead.
Okay.
Please go ahead.
Okay. So as we aware that a given fault or a shear zone is usually consists of a centralized core, which which basically experience the maximum shortening, and it consists of the highly deformed structure, and we also see the accumulation of a high strain within the centralized core, and these centralized cores are usually surrounded by the low strain or moderate to low strain damage zone structures. And these, when we talk about the type of structures that we usually find within the core, so a shear zone core usually consists of, if we are dealing in a ductilely deformed environment, so the core will usually consist of myelonites and ultramyelonites, and then your damage zone will consist of the protomyelonite. Protolith is the least deformed zone within which basically surrounds the damage zone in that region. But especially in the Himalayas, the chances of the preservation of the original protolith is quite rare because of the multiple deformation and metamorphic event. So we have tried to identify and map these different cores and their associated damage zones within the within the studied region in all three valleys. Along with that, we also performed the uranium-lead zircon geochronology, and to study the protolith characteristics of the rocks that are present in the region. So part A basically deals with the shear zone framework of the Munchiari and Vakrita thrust zones in the area. So in this particular part, I'll discuss the detailed structural and geological mapping that basically being performed in all three valleys. We are starting The main work was basically performed in the Alaknanda Valley, and it was followed by the similar kind of methodology was adopted in the rest two valleys, that is the Bhagirathi and the Dhaliganga Valley. So we'll first talk about the Munshari thrust zone, then we'll talk about the Vakrata thrust zone. So the Munshari thrust zone in the Alaknanda Valley, if we see it, if we see this geological map of the Munshari thrust zone in the Alaknanda Valley, so here we can see that this particular shear zone consists of several core and associated damage zone. Starting from the south, we could identify map the Gulab Koti core, which is a very thin, narrow core in the consisting of the Berina group of rocks of the inner lesser Himalayas. Then we identified the Gulab Koti Hilang damage zone, and then further north of it, we identified we demarcated the Munshari thrust, and on the hanging wall of the Munshari thrust, there was another structure that was identified as the Helang Lyari Penny core. So along with this mapping, we also we also tried to locate the different isogrades that are present in this valley. So in the hanging wall of the Munshari thrust, we located the garnet isograde, and then just above it we located the kyanite in isograde. So why the presence of these isogrades within the hanging wall of the Munshari thrust is important, that we'll discuss in the further slides. Uh, Along with that, if we see that on the stereo plot, if we see that, right, starting moving from the Gulab Koti core, that is the first stereo plot, up to the Lyari Penny core, that is the last stereo plot, there is not much structural discordance across the Munshari thrust in these damage zones and their corresponding cores. So the foliations, they essentially dip towards the northeast, and with along with the along with the northeast plunging, lineations were also present. So we also collected 4 samples from this across this particular Munshari thrust 1, 2, and 3 and 4 for the grain size and strain analysis that will be discussed in the coming slides. So now we tried a detailed mapping in this specifically in the Helang Lyari Penny core region to identify and map the different imbricates that are being present here. So in this particular map is the magnified version or the zoomed version of the Helang Lyari Penny core that is being shown here. So when we did the detailed mapping in this particular region, right in the immediate hanging wall of the Munshari thrust, so we could identify at least 6 imbricated bands of the quartzites from the footwall that were being appeared in the hanging wall Munshari group Nisis here. So these pink color units that you see here, pink or the orange color unit, these are the organ myelonites or the Semitic Nisis, which are highly myelonitized rock units which are present, which are basically representing the Munshari group in the immediate hanging wall of the Munshari thrust. And they were being transposed and they were being interleaved by these alternating imbricates of the quartzite, that are the yellow color bands that you see here, and these green color bands, these are the amphibolite bands, which are again basically belongs to the Berina group in the footwall. So the repetition of these quartzites or their occurrences of these quartzites and the amphibolite bands within the hanging wall, this tectonic interleaving on the map scale is because of the combined effects of isoclinal folding and foliation parallel top to the southwest ductile shearing that has been happened that has taken place here. And along with that, if you also focus on these metamorphic isogrades that we could locate here, so this is the garnet metamorphic isograde, and just above it we identified the kyanite isograde. Now the importance of the occurrence of these isogrades, garnet isograde if you talk about, or the kyanite isograde, is why they are important, because as the Waldia and the others, they have said that to identify the main central thrust or the Vakrata thrust in a region, the first appearance of kyanite in isograde metamorphic criteria is usually used to identify the Vakrata thrust or main central thrust in that region. So which means that the first occurrence of kyanite in any related to the Barrovian metamorphism will mark the location of the main central thrust, and above that main central thrust we will have the all the rocks that will be within the kyanite isograde, and the footwall rocks will be devoid of this kyanite isograde. But this entire section that we see here, it is in the footwall of the Vakrata thrust, because further north of the main Munshari thrust, we have the Vakrata thrust. So this entire unit is lying in the footwall of the Vakrata thrust, and within the footwall of the Vakrata thrust, we are also we also observing the kyanite in isograde. So this raises a question that there is no contrast in the kyanite isograde across the thrust, and kyanite is appearing on footwall and hanging wall side. So does it mean that Vakrata thrust has shifted to the lower boundary close to the Munshari thrust, or we should look for some other sort of evidence to identify the Vakrata thrust? So based on that, we did the mapping of the Vakrata thrust zone in the same region. So before that, I would like to show you, these are some of the field photographs that gives the evidences of the moderate to low to moderate kind of brittle deformed structures that are present. This photograph A is from the Gulab Koti Hilang damage zone. So usually these damage zone consist of these type of brittle pinnate joints kind of structure that represents low to moderate joints. And if we move into the Helang Liari Penny core, which is a high strained core, so in that the photograph from B to D, all these three photographs are from the Helang Liari Penny core, which basically consists of the very highly deformed structures. Like if it can be seen in this photograph, see where top to the southwest myelonitized SC fabric can be seen. In photograph D, it can be seen that these SM2 myelonitic foliation, it is basically transposing these tight isoclinal fold limbs has been cross-cut by these SM2 myelonite foliation, and with due course of progressive ductile shearing, ultimately these older myelonite foliation, that is SM1, becomes parallel to the younger SM2 myelonite foliation in that region. In photograph B, it is clearly visible that these light color rocks that are basically the Berina quartzites, they are being interleaved and along with the myelonite niches that are present. So these quartzite that we see here, they are from the footwall Berina group rocks, and these myelonites that you see, that these darker color rocks, they are from the hanging wall Munshari group niches. So the alternation between these two different rocks from the footwall and hanging wall is being basically taking place within the Helang Liari Penny core. And it can also be seen here that this decameter scale quartzite band is being isoclinally folded, and ultimately these isoclinally folded quartzites and myelonite bands, they are basically transposed by several top to the southwest shear zones that are present in that region. Because of this uh, combined effect of the tight isoclinal folding that is being observed in the region, and ultimately their transposition because of the progressive ductile shearing. So because of all this combined effect, this uh, repetition in the different rock units is being observed within the Munshari group rocks. Then we also tried to study the different kinds of fold geometries that we could identify in that region. So broadly, within the Munshari group nices in the Helang Liari Penny core, we identified three broad fold geometries: F1, F2, and F3, where F1 are the isoclinal folds, and they vary from isoclinal to reclined rootless geometry. And F2 folds are essentially the ones that are formed because of the coaxial refolding of the F1 fold, and to form the type 3 interference pattern here, as it can be seen that this is the F2 fold, which is formed because of the coaxial refolding of this earlier F1 fold. Then there is another group of fold which is the F3 fold, and these F3 folds are usually formed because of the non-coaxial refolding of the earlier F1 or F2 fold, as it can be seen in this photograph. See that this is the F2 fold. Now this F2 fold has been refolded non-coaxially to form the F3 fold, as it can be seen from this schematic diagram. So now, these all three sets of fold groups that we could identify in the region, they were again subjected to progressive ductile shearing because of the movement along the Munshari, ductile shearing along the Munshari and the Vakrata thrust zone, and ultimately the F1 or the F2 fold were uh, basically affected by these top to the southwest progressive ductile shearing because of the Because of that, the earlier lineations that were present parallel to the fold hinge of the fold axis of the F1 and F2 folds, they were rotated to form these type of sheath folds which are being present here. So this is the photograph that you see in A. This is the cross. This is the long. This is the transverse section of the uh, basically a tactile, basically a sheet fold geometry that you see here. And we also tried to calculate the overall aspect ratio of this sheet fold geometry that you see, which basically represents the overall aspect ratio of 0.77. And this R dash, that is the ratio of the outermost axial ratio divided by the innermost axial ratio. It is 0.77, and which says that it has a cat size geometry. And this type of geometry usually indicate the dominance of simple shear in the region than the pure shear deformation. And then we also tried to plot these sheet hinge lines data and along with the intersection or stretching lineations that were present here. So as it can be seen that all the intersection or the stretching lineations, red color points, they basically coincide with the sheet hinge lines, and they all these hinge lines or the stretching lineations, they all plunge towards the northeast direction. So this basically gives us the hint that the earlier lineations that were present, they were basically rotated because of this top to the southwest progressive ductile shearing to form the present type of sheet folds in the region. And the evidence of the transposition of these isoclinal folds is also being shown in this photograph D and E, where you can see this is the isoclinal folds that are basically present here, which are representing the F1 or F2 type of folds. Or you can see in this photograph also in D, this was initially a kind of a isoclinal fold. Now because of the lateral transposition, because due to the top to the southwest ductile shearing that happened in the region, these shearing has transposed these limbs, and now these limbs appear as tectonic horses. Like if you can see here, this is kind of top to the southwest thrusting happened. Because of these limbs override one and each other, and now they are represented as the tectonic horses. Uh, Now this particular phenomena, the mechanism that you are seeing here, this has taken place from centimeter scale up to the meter scale and up to the map scale. And based on these observations, we identified these type of different imbricate zones within this entire region. And this is the reason why these different bands of the football Berina quartzites or the amphibolite are being repeated within the given Munshari group nices. Now, along with that, we also tried to perform the grain statistical and strain analysis, SC fabric dihedral variations. So for that, basically we took few samples from the footwall of the Munshari thrust, and then we took few samples from the hanging wall also, and then we did the grain size and grain area analysis along with the strain estimation. And now this everything was also combined with the SC fabric dihedral angle variation. So as we are aware that Munshari thrust is present here, so as we will be approaching closer to the Munshari thrust right from the damage zone towards the core, so the overall strain will increase. So because of this increasing strain in the from damage zone to core, so the overall grain size of the recrystallized quartz grains that you see here, the recrystallized grain size will also decrease and the strain will also increase. So this can be clearly shown here. As you can see here, this particular starting from A at the bottom, it has got a mean grain size of 216 and grain area of 29. As we move closer towards the Munshari thrust, grain size decreases to 195, grain area also decreases. Now again, as we cross this thrust, and if we move again, so as now we are moving away from the thrust, so grain size will increase as well as the grain area will also increase. Now if you combine it with the strain estimation that we perform, so as we are moving closer to the thrust, strain ratio is increasing from 1.8 to 1.37, and as we move away from the thrust, it decreases from 1.82 to 1.56. Now it is when combined with the SC dihedral angle. So if we are at the core of the Munshari thrust, then at the core of the, so basically the rocks that are from the hanging wall of the Munshari thrust, they are representing the hanging Helang Liari Penny core, and the footwall rocks are representing the Helang damage zone. So if you are moving towards the core of the particular shear zone, so because of higher strain accumulation, the dihedral angle between the S and C fabric will also decrease. So it can be clearly seen here that the dihedral angle between S and C fabric is between 10 to 30 degree in the core region of the thrust, whereas it is between 30 to 50 degree in the damage zone of the thrust. So because of all these evidences, we could identify the different damage zone and the core in the region. Now, to give the evidences of the kyanite isocrates that we identified in that within the footwall of the Vakrita thrust. So here you can see. So basically, two important isocrates were the garnet and the kyanite isocrate. So if we see the talk about the garnet one, so garnet basically appear in three forms. Either it appear as the stretched garnet that basically follows the F2 fold. So here you can see this is one of the stretched boudinaged garnet. So these boudinaged garnet are present everywhere all along this F2 fold, or they also appear as the ductilely folded garnet bands which are here. Although uh, it, it is very difficult to deform the garnet in a very ductile fashion. So this basically gives us an hint that how much amount of strain that is present, that it was able to ductilely fold the garnet in the region. And these garnets also show the snowball type of ductile shearing with top to the southwest ductile shearing. Along with this garnet, we also identified the kyanites in the footwall of the Vakrita thrust within the Munchiari group. And so all these photographs are from the Helang Liari Penny core, which is basically the Munchiari group. So here you can see these are the kyanites. They either appear parallel to the myelonite foliation SM1, or they basically appear along the folds of along the F2 fold, and appearing as the inclusion within the plagioplace. So the occurrence of these kyanites and garnets in the footwall of the Vakrita thrust uh, force us to rethink over the metamorphic isograde criteria as one of the identification criteria to locate the main central thrust, as it is appearing on the footwall as well as on the hanging wall side. So now we did the similar kind of methodology within the Vakrita thrust zone also in the same valley. And here, uh, as of now, the workers have been using the same definition given by the Valdia to identify the Vakrita thrust or the main central thrust region in that region, which was based on the metamorphic isograde, which was that the first appearance of kyanite in that region will mark the initiation of the greater Himalayan sequences and the main central thrust in that region. So now, so this kyanite isograde that you see here, this pink color one, this is the kyanite isograde that is marked by the Thakur and others, and this is based on the findings of the Valdia and Thakur. Based on this kyanite was marked here, but the kyanite isograde that we have marked, it is much at the lower structural level in the footwall of the Vakrita thrust. So this again raises the question that Peruvian kyanite mineral assemblage is not the suitable criteria. In contrast, then uh, what should be the criteria to basically identify the main central thrust in a region? So in contrast to this study, in contrast to that, we performed the shear zone framework and strain distribution, and we could identify a very high strain Ceylon core that was present in that region. And based on the presence of this Ceylon core, where the maximum strain accumulation occurred, we identified the Vakrita thrust in that region. And coincidentally, the Ceylon core that we identified, it coincides with the kyanite isograde that was marked by the earlier workers. And the this particular stereo plot that you see here, this again indicate that as said by Valdia, that there is a deformation, change in the deformation style and the orientation of the structure across the Vakrita thrust, but we do not see such type of discordance in the structural data, as it can be seen that the foliations are again pointing towards the northeast tipping direction. Although there is some sort of scattering in the lineations that are present on the hanging wall side, so it is true that there is some sort of more tight isoclinal folding happening within the footwall as compared to the hanging wall. So again, to locate this Selangor in region, Selangor in that region, we again performed this grain statistical and strain analysis, and again then we took few rocks samples from the footwall. Then this sample, that is C, was from the Vakrita thrust, within the Vakrita thrust, and then two samples were from the Helang. This is the hanging wall of the Vakrita thrust, and then again on based on this criteria, we observed that a strain accumulation of strain ratio of 3.14 was observed within the Vakrita thrust, that is from the Selang core, and this coincides with the minimum SC fabric dihedral angle which is also present. So the minimum SC fabric dihedral angle, maximum strain ratio, and the minimum mean grain size and grain area compels us to identify this Selang core as the Vakrita thrust in that region. So now this same kind of methodology we adopted in the Bhagirathi Valley also, and based on this we identified several damage zones and the core in that region. So I'm not going much into detail in this because this is similar kind of methodology. And then we also did the same type of methodology to identify the Vakrita thrust zone rocks within the Bhagirathi Valley. So here again, the same set of tectonic forces of the footwall and the hanging wall rocks was seen within the Vakrita thrust zone, where this light green color is basically the phylonite zone that is present in the Bhagirathi Valley. And within that phylonite zone, these are the imbricates of footwall and hanging wall rocks that are being repeated over one another because of the same reason, that is the isoclinal folding transposed by progressive ductile shearing to the southwest ductile shearing. Now, similarly, we did the mapping in the Dhauli Ganga Valley also. Unfortunately, in the Dhauli Ganga Valley, Munshari thrust does not get exposed along the road section, whereas it get exposed somewhere in the higher elevations, which was inaccessible to us. But we could identify the Vakrita thrust zone here, and on contrary to the previous two valleys where the Vakrita thrust zone was either present as a very high strain zone or it was present as a ductile shear zone, in this valley the Vakrita thrust zone is exposed as a fault gouge zone. If you can see in this photograph B is from the Tapovan damage zone, and this photograph A is from the Tapovan core, which is this myelonitized zone. And basically this Tapovan damage zone coincides with the Vakrita thrust zone, because north of this particular region we get the greater Himalayan rocks, and in the footwall we have the lesser Himalayan rocks. So this particular outcrop that you see, this cliff-like forming fault gouge zone, as it can also be seen in the thin section, that these very angular shaped quartzite clasts are present in a very fine grained powdered matrix, which is non-foliated, representing the fault gouge. So these fault gouges are basically formed by the pulverization of the lesser Himalayan quartzites and the myelonite rocks that are present here. So based on all these studies in all three valleys, we came up with this tectonic model and this tectonic model is mainly based on the studies performed in the Alaknanda Valley. And here we could identify several imbricate horses that are present within these Munshari thrust zone and the Vakrita thrust zone rocks. These tectonic imbricates that you see, this yellow color band and as well as this green color amphibolite band, that are representing the tectonic imbricates of the Munshari group, footwall Berina group rocks occurring within the Munshari group rocks. Along with that, when we combine the structural data from the Munshari thrust zone as well as from the Vakrita thrust zone, we do not see any significant structural discordance across the two thrust zones, which states that there is not much structural discordance across the two thrust zones, although a higher strain accumulation is being observed along the Vakrita thrust as compared to the Munshari thrust. And so this marks the overall structural findings from that region. And we can state that Munshari thrust is well exposed, distinct intra-lesser Himalayan tectonic structure across the valley section, whereas Vakrita thrust, the surface manifestation varies from brittle fault zone in the Dhauli Ganga Valley, and it goes to ductile shear zone in the Bhagirathi Valley. In the areas which lack distinct surface expression, where basically the Vakrita thrust is not exposed on the surface, in that situation, the Vakrita thrust can only be discerned through the identification of the high strain anomaly And we also say that the unambiguous occurrence of Peruvian kyanite across the Vakrita thrust suggests the kyanite in isograde criteria is untenable for delineating the Vakrita thrust. So that is from the part A. I think if there is time, can we move to the second part? I don't know
I think yes.
because I took a bit time.
Yes, you can take like 10-15 minutes.
Okay, okay. It is a small one.
Yeah.
Okay, so the part B is mainly related to the protolith geochronology of the Munshari thrust zone rock. So basically, we tried to do in this particular part, the main approach was to come up with a novel methodology to basically constrain the depositional age of the inner lesser Himalayas. So so for this, basically what we did, this is the combined map of the entire region in the along the Alaknanda Valley. So here we took two samples from the Berinag quartzites, which lies within the Gulabkoti Hilang damage zone. So this red color star shows WRG 2x2 and 2x3, which are the quartzite and chloride schist, which basically occur as intercalated units in that region. And we also took one sample of quartzite from the previous published data of Mukherjee 2019, and this has the same characteristics as the quartzite that we took. So we combined it for the better comprehension. So now, before proceeding to this part of second part, this part B of this presentation, there is a bit background and roadmap that why when you are trying when we try to constrain the age of a sedimentary succession. So the primary aim in this particular part was to constrain the true depositional age of the Berina group. Although several workers have given the maximum depositional age of the Berina group, which varies from 1.95 to 1.75 billion years, right here, and with a broad age spectrum of approximately 200 million years. But we do not have a very accurate age of the depositional age of the Berina group in the inner lesser Himalayan part of the region. So for that, we know that to constrain the age of any sedimentary succession, there are two ways by which we can constrain the age. First one is the maximum depositional age, or either we can go for the true depositional age. So whereas this maximum depositional age gives us the youngest possible age of deposition, which is constrained by the youngest detrital zircons or the group of zircons that are present within the given sedimentary rock. And then there are several mathematical statistical tools methods that are present to give the maximum depositional age. For example, YSG, that is youngest single grain age, YDZ is the youngest detrital zircon age, YGC is the youngest grain cluster with 1 sigma uncertainty or with 2 sigma uncertainty, or the youngest graphical peak, and the tough zip. So these are some of the methods which basically most commonly used to constrain the maximum depositional age of any sedimentary unit. But these of maximum of most of these methods have low precision and accuracy because of the analytical and instrumentational uncertainties, and the age spectrum that they give, it is a very broad age spectrum, so we do not get a very unique age of deposition. Whereas if we go for the true depositional age, it will give you the actual age of deposition, and it is usually constrained by the independent chronological methods. For example, we can date the penny-contemporaneous volcanic flows, igneous intrusion, or the biostratigraphic markers, provided this particular method will work only if you have these type of independent chronological methods present in that region. So this is not possible every time you go for the true depositional age, but wherever this is possible, wherever you have these type of penny contemporaneous volcanic volcano-sedimentary flows, then we can go for this type of methodology because it is high in precision and accuracy, and it is verified by independent methods, and it is more reliable. So when we talk about the inner lesser Himalayan units of the Garhwal Himalaya, so this particular unit basically represents the Paleoproterozoic magmatic arc during the Columbian supercontinent assembly, as reported by the Mukherjee in 2019. So this particular Paleoproterozoic magmatic arc, it consists of two major groups which are now present in the Himalayas as Munshari group and the Berina group. As we have seen already, they both are separated by the Munshari thrust, and towards the north of Munshari we have Munshari group, and towards the south we have the Berina group. where the in this magmatic arc setup, the Munshari group represents the magmatic arc which was present during the Columbian supercontinent, whereas the rocks in the Berina group represent the rifted back arc basin setup. So this particular Berina group, which is basically representing the rifted back arc basin setup, it consists of the penny-contemporaneous volcano-sedimentary sequences of intercalated quartzite and chlorite schist rocks. So the maximum depositional age, as we have discussed, of these particular rocks have been given varies from 1.95 to 1.75 GA, but there are mainly in the Garhwal Himalayas there are no records of the true depositional age of this particular unit. However, there are few records of the actual depositional age that are from the Himachal and Bhutan Himalayas, given by Miller, Richards, or the Kohn. So, through this study, we try to determine the true depositional age of the Perina group, and we try to compare it with the reported maximum depositional ages in that region. So for that, we need to look for the outcrop relationship here. So this photograph A shows the alternating intercalated penny contemporaneous sequences of these light colored quartzites, and these light green colored are the chloride schist rocks, which are foliated, which are basically aligned with each other along the SM1 foliation. If we give the closer look here, so this green color rock body shows the chloride schist, and this white color one shows the quartzites. And these rock types, they were basically collected from the footwall of the Munshari thrust in the Alaknanda Valley. Along with these two rock types, we also see the amphibolite units, thick amphibolite units, which were being shown as the green color bands in the Berina group. So these amphibolite bands, when we see it in section, so they essentially represent the somewhat textures of the volcanic flows that were once present here. Now these volcanic flow textures now are metamorphosed to form these amphibolite rocks. So several geochemical and petrographical studies have been performed in this particular valley, and these studies identify the protolith, identify the mafic volcanic flows or the ash as the possible protolith for the amphibolite and the chloride schist rocks that we see here, which now are present as the metamorphosed chloride schist rock units, metamorphosed to the green schist to the lower amphibolite facies. And if we see in this photograph number E, this is representing the thin section photograph of the chloride schist. So in this photograph, we see that more than 90% of the area is basically being covered by only the chloride flakes. So because of the so this particular chloride schist is representing the retrograded volcanic flow horizons, which have been subjected to several phases of metamorphism. So because of that, the original texture of the volcanic rock is lost, but the geochemical studies have shown that the protolith of these chloride schist or the amphibolite rocks that are present is essentially the volcanic flow horizons that basically have occurred during the Paleoproterozoic time. And if we see the inset, on the inset we see this quartzite. If you see here, so these type of very anhedral angular shattered quartz grains, or not quartzite, quartz grains present within these thin within these chloride flakes, within this chloride schist. So appear the presence of these quartz grains appears to be indicative of the presence of the quartzite and pure
Hello.
amphibolite, pure chloride schist units. Yes.
Yes, yes. Please continue. Continue.
Okay. So now what we basically did, so we had the two samples. One was the quartzite, and second was the chloride schist. So basically, in the first case, we performed the applied. Hello.
Ah, Yes, Rahul, please go ahead.
Yes, okay. Spontaneous volcanic metavolcanic chloride.
Hello. Sir, I think there is some problem in the connection. Hello.
Will constrain the age of the deposition in that area. So from that we can say that the age of the metavolcanic crystallization age of these metavolcanics may be equivalent to the true depositional age of the Berina group, which is 1879 plus minus 16 mm. Then we also try to compare this age of true depositional age, that is 1879, from the 7 methods of MDA methods that we applied on the quartzite. So here it can be shown in that this particular this particular line represents the true depositional age of the quartzite obtained from the chloride schist, and these four methods, which is basically the method number 4, that is YGC1, YGC2 sigma, method number 6 YGP, and method number 7 tough, they give the results which are within the uncertainty limits of the uh, true depositional age, whereas these two methods 2 and 3, it is beyond the uncertainty.
Hello, Rahul. Hello, some internet connection
I
issue.
think there is some issue with the connection.
Yes, yes, Rahul.
Arun, please
Yes,
check with
yes.
him.
Rahul, hello. Yes, sir, let me call him. I think some internet issue is there.
I think that's better.
Yeah.
Call him.
हेलो.
Internet
हाँ
issue?
सर, वो इंटरनेट ही चला गया डिपार्टमेंट का.
Yeah.
अभी मैंने कनेक्ट किया है, देखिए अभी
हाँ हाँ आ रहा है अभी
मैं
आ
कर
गया या यस
आगे सर.
यस यस हाँ या you can reshare your screen.
इज इट विजिबल नाउ?
Yes, 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 please.
ओके. The quartzite, as you can see, and these are the CL images from the chloride cyst. So we can see in the quartzite, all these zircons,
Just
they
a
show
moment, Rahul.
very
Just a moment.
yes.
Till the end of your lecture, you keep your video off. I think due to
Okay.
the bandwidth, there is some problem. So it's better you keep
Okay
your
sir.
video off for the timing. Then you can
Okay sir.
open it again during the discussion.
Yeah, yes, that's a good
Okay.
suggestion.
So we can say that here the quartzites, basically they show very euhedral kind of shape, and with very less rounding is being shown here, seen here. So if we did the grain size analysis, we try to compare the roundness of the quartzite zircons with as compared to the chloride schist, and we could see that the roundness of these zircons that are present within the quartzite, they show a mean value of 0.37, which is a very low value. So, which shows so that a low roundness of these quartzite, the tetrahedral quartzite grains that are present with the tetrahedral zircons that are present within the quartzite. We also compared the overall age distribution that was being obtained from both two rock types, chloride schist and quartzite, and we did some sort of quantitative descriptor analysis. So here we can see both the samples, chloride schist as well as the quartzite, uh, they essentially show the unimodal age distribution, which is centered somewhere around 1800 MA, and based on these values of r square, s, or the p value, which represents the basically which tries to give you the hint that the both age distribution in both the sample is quite similar to each other, and they possibly have a similar kind of age distribution. So based on that magmatic characters, low roundness, unimodal age distribution, we can think we can say that the source for the detrital zircons within the quartzite must be a near depositional one, and so the detrital zircons that are present within the quartzite, they must not have traveled far from their source, and they were deposited in a very near basin. So since these quartzites are representing the rifted back arc basin, so their source of these rifted back arc basin sedimentary material must have been somewhere within that region, which is very close to that. So for that I'll come to this slide later. So for that what we did, we uh, tried to basically look for the magmatic edges of the overlying magmatic arc that is basically being presented by the Munshari group. So in this graph, what we basically did, we take a total of 45 edges, published edges of the orthonice, which basically represents the Paleoproterozoic magmatic arc in the lesser Himalayan sequence all along the Himalayan origin, and we tried to we plotted them on this graph, and try to compare the average age, that is ty. So the average age of all these published orthonices from the different papers came out to be 1858 plus minus 15, and whereas when we compare it with the maximum depositional age, that is tx, that we got in our work, the maximum depositional age of the quartzite in our work, it came out to be 1871 plus minus 5.3. So the orthonices and the quartzites in the footwall, they both share the similar kind of age, which again hint or indicate that the possible source of these quartzite zircons must have been these immediately not lying northern magmatic arcs, which has a somewhat closer. Compare the results that we got in our study, which the true depositional age of 1879 plus minus 16 MA of the quartzite with the published data, previously published data, and it came out to be well in accordance with all the published data. So based on that, we say that the detritus in the rifted back arc basin, which is present day Berina group, was predominantly derived from a proximal northern felsic plutonic source, such as the Munshari group, with minor input from the southern parts of the Indian shield. So there have been reports of the input within drifted back arc basin from the southern part, that is from the Aravali or Bundelkhand Creton also. But we are not denying the fact that the input was not from there. It was also from there, but based on the results that we have got here, low roundness, unimodal age distribution, and the similarity between the maximum depositional age and the true depositional age, it hints or indicate that the source of the Berina group was somewhere near the region, that is possibly the Munshari group gneiss. So this has been shown in this proposed model by Mukherjee and others 2019. So here it was the Munshari group was during the Paleoproterozoic time. It was Munshari group, the present day Munshari group was representing the Paleoproterozoic magmatic arc, and then when this slab was subducting, so after the initial subduction, there was a period of extension because of the slab rollover and pushback. Because of that, a period of extension happened, and because of that extension, a rifted back arc basin was formed in the overriding plate, and within that region, the volcanic flows were there, and the clastic sediments that were being deposited here, they were immediately transported from the nearby Munshari group rocks, and all these volcanic flows, clastic sediments, as well as the Munshari group rocks, they show a similar kind of age distribution. So based on that, we can say that the unimodal zircon age peak in quartzite and metavolcanic chloride sits, supported by the field and microstructural evidence, confirm the penny-contemporaneous character of the volcano sedimentary sequence of Berina group. True depositional age of Berina group is 1879 plus minus 16, which is based on the crystallization age of the penny contemporaneous Himalaya system. So the active northern Indian continental margin, witnessed concurrent mafic flows which are represented by the chloride schist, maximum depositional age of the Benina group is 1871 plus minus 5.3,
Hello,
which is
Rahul.
constrained from the Vaigizi 2
I
sigma
think
method,
he
which
again
came
lost
out
the
to be
signal.
the best method for constraining the maximum depositional age of the Benina group. So the active northern Indian continental margin,
Hello, Rahul. Can you hear me? हेलो. हाँ राहुल. अभी आया है. ओए,
I
अभी नहीं.
think he is disconnected.
I think so. नहीं, he's connected, but I think he has lost his signal, internet signal. Uh, okay. अभी फिर से एक बार ज्वाइन करो. So I have called him. He will join. So I think he will join again.
Okay. Okay.
हाँ, hello
hello,
Rahul.
am
Yes.
I
Yes, yes, yes.
yeah, am I audible?
Yeah, yes.
Sorry for the
हाँ,
internet glitch. Actually, it's I'm in university and here internet is not working well. So, should I share again my
yes,
screen?
yes, yes. You're in the last slide. Conclusion slide.
Okay, okay. So to conclude the part B of the presentation, that is the protolith geochronology. So unimodal zircon age peak of 1880 in quartzite and metavolcanic chloride schist, supported by the field and microstructural evidence. They confirmed that the penny contemporaneous character of the volcanosedimentary sequences of Berina group. We obtained the true depositional age of Perina group at 1879 plus minus 16 Ma, which is based on the crystallization age of the contemporaneous mafic flows, which are represented by the chloride schist. Maximum depositional age of the Berina group is 1871 plus minus 5.3, which is constrained from the YGC 2 sigma method, which came out to be the best method for constraining the maximum depositional age if the true depositional age is not viable in that region. So the active northern Indian continental margin witnessed concurrent mafic volcanism, sedimentation, and felsic plutonism within a relatively brief time frame during the late Paleoproterozoic at around 1.87 to 1.86 G. So that is all from my side.
Thank you, Rahul. Now the platform is open
So,
for discussion.
Yeah. Can I ask first
Yes, sir.
so
Yes,
that
sir. Yes, sir. Please go.
yes, please.
I can just. Rahul, it was a fantastic talk. I really liked it. And you have done
Yes,
a detailed work there in the Alaknanda and Dhaliganga Valley.
yes. Thank you.
So, I'm just asking one thing that you have not found any uh, differences in the structural style from Munchiari to
Uh,
Vaikrita, right?
hello,
As you said. Can you hear me, Rahul?
hello.
Hello? Can you hear
So
me?
your voice is not audible.
Oh, hello? Can you hear me?
Hello, Rahul. Hello.
I think again there is some
Yes.
issues with the
Yes.
internet. Okay, Arun,
Yes, sir.
you continue with it. I'm
Okay.
just putting myself
Hello.
off and I'm going inside the hospital.
Oh,
Okay.
okay, sir. Okay. Yeah, Rahul. Hello, can you hear me, Rahul? Hello. हाँ राहुल बताइए.
सर आवाज नहीं आ रहा है वो सर क्या क्वेश्चन पूछ रहे
नहीं
हैं?
पता नहीं तुम्हारा माइक
Arun, you try to
नहीं उन्होंने क्या पूछा
turn
मुझे
the
सुनाई
audio
नहीं दे रहा
from
ना,
your
मतलब
mobile.
उनका वॉइस नहीं आया.
Yes sir, I'm contacting him right now. Yeah. Rahul.
And
Yes. वो फिर से I think फिर से join
you are
करेंगे.
using two devices, Rahul, I think. So you continue with one of the device with your audio and with the other one with your PPT. I think
Yes, that's why I think he has joined through.
that would
I've, yes,
solve
I've
this
asked him
problem.
to rejoin.
हेलो. यस
Rahul.
सर.
Yes. Rahul. Yeah.
यस सर. यस सर.
Yes. Yeah.
So,
So,
can you sir please repeat your question? I couldn't listen to you.
sir has some other commitments. I think he's left.
Okay.
Rahul, actually, Shantanu sir has left because he is entering a hospital.
Yes.
Okay.
What I could frame from whatever I could hear, he was asking about that whether there is a difference in the deformation styles between the valleys, between the Bhagirathi and the Dhali Ganga, because I know he
Uh,
has been to Dhali Ganga a couple of times, Shantanu sir, that I know.
yes.
And uh, means he has also visited the Bhagirathi and Alaknanda Valley. So I think that's
Yes sir.
why he was asking that
Okay.
whether there was any
Sir, actually
similarity
the
or
overall.
dissimilarity, or if there are, then what are the kinds of dissimilarity between these two valleys?
Okay. So if we try to look at the compare the uh, deformation style in the Alaknanda and the Dholi and the Bhagirathi Valley, so we could identify that in the Bhagirathi Valley, see, the Munshari thrust is itself a folded thrust. If you see it here in this in this slide, so the rocks in the footwall of the Munshari thrust, they form a very gently northeast plunging antiform, as well as the rocks on the hanging wall also form a very gently northeast plunging antiform. And based on that, we could identify that here the Munshari thrust appear as a folded thrust with oblique slip top to the southwest thrusting. So this is one thing which is in contrast with the Munshari thrust deformation style of the Munshari thrust that we saw in the Alaknanda Valley, where it was not folded and there is not much structural discordance that was observed across the Munshari thrust, as it can be seen here that the foliations they essentially trend towards the northeast with a very tight centered northeast plunging lineations across the Munshari thrust. And one thing that is another point to observe is that in all three valleys, whenever we cross from the uh, Vakrata thrust footwall to the Vakrata thrust hanging wall, so hello.
Yes.
Uh,
Can hear you, Rahul. Please go
Yeah.
ahead.
So when
yeah.
yeah,
Go ahead,
so
go ahead.
whenever we yes sir. So whenever we whenever we go across the Vakrata thrust, so the lineations that we see here on the footwall, they are tightly clustered toward plunging towards the northeast direction. But as we move in the hanging wall side, so there is a bit quite significant scattering of the lineations is being observed on the hanging wall side. And this is common in other three valleys also, that is Alaknanda, Dhauliganga, and here also Bhagirathi also. So this possibly may be because of the sudden release in the accumulated strain from the footwall towards the hanging wall side. Because when we did the strain analysis, so we could identify a high strain accumulation towards the footwall side as compared to the hanging wall side. Of course, for that we need to do more sampling and more strain analysis in that region.
Okay. Just in continuation to this question, I would also
Yes.
like to know that to determine that your Munshari thrust is folded, what data actually you took? Stretching lineations only, or something else as well?
So
Where you
to
only
in
Munshari
the
thrust is
yes,
folded just
yes,
before this, I think.
so here
Yeah.
basically, sir,
Yeah.
sir, so to observe the folded nature of the Munshari thrust, basically we took the lineation, stretching lineation, and the foliation data on the footwall side. That is, the bedding planes are being shown in the first stereo plot, as you can see here. So these blue color dots representing the bedding surfaces, and these red color dots are representing the lineations in that region. Basically, we did not separated the mineral lineation from the stretching lineation. So overall, the type of lineations that were present, we combined them and projected them here. And then similarly, we also did the measured the data on the hanging wall side. So here also we could identify that across the river that is flowing there, across the river there was a change in the orientation style of the foliations that are being present, S1 foliation specifically. So these are
Rahul,
the
Rahul, Rahul, one thing for this Munshari thrust
yes, sir.
means for the data that you have taken from the hanging wall side, it's fine if you are relying on that. But how far you can say that the footwall data, your bedding surface, or for example some foliation, will help you to identify the geometry of the thrust exactly. Uh, this point I'm not
Sir,
uh, uh, is getting particularly this point, the footwall that you are just
yes,
mentioning.
sir, it is
Fine,
that's why
there is
yes.
a footwall fold that I can see from your data.
Hmm,
Okay,
hmm.
but
Yes,
whether the thrust will mimic that fold or it will simply be parallel or subparallel to that fold, how you can say that? Because it is in the footwall. From your data, I can see there is a small band, means thin band that you have shown. That's fine
hmm.
from your footwall data. But how far you can rely on the footwall data to determine the orientation of the thrust itself? That is my concern. The first concern. The second one is that if you are taking myelonite foliation, it's fine. There is no problem with that. But your myelonite foliation in the thrust zone and away from the thrust zone can also vary. Whatever data you have taken, is it from the damage zone only, or it is
Damage zone only. For hanging
damage
wall
zone?
damage zone and footwall damage zone.
Okay, okay, okay. But the whole thing, I'm a little confused. That if you have a geometry here in the footwall,
Yes,
it's
sir.
fine.
Yes,
There is
you're
no
saying
question
that is
about the
right.
footwall geometry. But how far we
Hmm.
can means
So,
compare
sir,
that the
that is
thrust
why.
geometry will be almost same
Hmm.
with the footwall. That's a bit complex in my
Yes,
view. I
that
don't know.
needs to be
Maybe
again
others
checked.
might.
So basically, we have said that it is one of the possibility that it could be folded, and but we
Okay.
need to again check this thing that you are saying it is correct, and I need to look into it
I
again.
think Rahul, you have data both from footal and also hanging wall. Huh?
Hanging
Is
on
yeah, B and D both are like
E and
yeah,
D.
both
And
fully folded.
within the core where we have marked this Munshari thrust, actually there was a very highly deformed narrow zone. So there we could not look for the more observation. But here also you see the lineations that were present. They are northwest
No, that is fine,
plunging.
Rahul. I'm not criticizing or questioning your the interpretation. I'm saying that relying on the hanging wall data is fine, no problem.
Hmm.
But saying that considering the footwall data, that statement is not very true, I think. That's my concern. I'm not saying your data is not reliable or it's
Yes.
not like that. There is no question. You have taken very good data that is very well illustrated here as well. So there is no question about that. I'm just thinking about that part. And one, I think another, in your
Yes, sir.
second part, in your geochronology part particularly, you have told us about your depositional ages. It's
Yes.
again your data and the ages that you have said. It's pretty fine, and the thing is that it is also in accordance with other publications that I've seen. But
Yes.
what I would like to know is what is exactly the main focus or main purpose of finding out these depositional edges, how far your means structural anatomy of these zones that like you have titled your talk structural anatomy, how far these depositional edges are going to help you to determine that. Is it only due to for the protholic characteristics? That's the second part of your talk, I think, or it is
Yes,
also
sir.
complementing your
Yes,
structural
actually,
data.
sir. So
Just like to
this
know.
was yes. So this was mainly to characterize the protolith of the rocks that are present within the damage zone of the Munshari thrust. So what have been the overall
Okay.
depositional history of the rocks that are being present here? So the main focus of the part B was to look for a novel methodology by which we can constrain the actual age of deposition, as I showed in this particular uh, slide, that there are several methods that basically several workers use to identify the depositional age of the rock, and because of that the same rock unit has got several depositional ages, and because of that if you see here, many
Mhm.
workers have used adopted these criteria, different statistical criteria, and because of that we have got a broad age spectrum of 200 million years. So some people say that the age is 1.95 to 1.75, and this is within the same Garhwal Kumaon Himalaya only. So that is why we have adopted this methodology so that we can more precisely pinpoint towards the actual age of deposition, because the contemporaneous flows will largely constrain the age of deposition in that region. So that is why we have went for this particular methodology,
Okay. Okay.
and
So,
this
so
is
that is
especially
not directly complementing your structural conclusions. It is for
no,
mainly your
not in this.
protholic
Actually,
characterization.
yes, sir. Actually, sir, I have not shown the other part of geochronology work, basically because it is not yet finalized, that I was discussing here. That we
Okay.
have also basically got some of the imprints of early Paleozoic tectonism that have affected the MCT movement. So this part basically I have not covered here as it was not yet finalized. But we
Okay.
have got the
This 23 to 11, 9 to 6 mm, these, I think these are exhumation edges.
uh, no, sir. This is the not the exhumation. This is based on the cross-cutting relationship that Mukhopadhyay reported 22 somewhere, 22 million years somewhere.
Okay, these are not absolute, not your absolute dating methods. These
No,
are
no,
all relative.
relative methods that have been.
Okay, okay, okay.
And so we also could identified early Paleozoic tectonic events which have been
I
occurring
think,
within the
I
main
think there
sequence.
are some data recently, not only recently, since a few years back, uh, some exhumation dates are available from R.C. Patel search
Yes,
publication. If
yes,
you can
yes.
compare
Patel,
that,
yes.
I
Patel
think
sir
that
has
would
done that.
directly complement your structural interpretations.
Okay.
That's my
Yes,
suggestion.
I'll look into it. I'll look into it. Thank you.
Yeah, I think Arindam Das has raised his hand. Arindam Das, you can go.
Yes, sir.
Yeah. Am I audible?
Yes, yes, yes.
Yes, sir.
Please go.
Yeah, yeah. Rahul, I have two questions for you.
Yes.
The first one would be you have shown two thrusts. One is Munshiri thrust, and the one is Bakrita thrust.
Hmm.
Can you please tell what is the exact thickness, means what is the exact or approximate thickness of both these shear zones, the Munshiri thrust
See,
zone as
yes.
well as the Bakrita thrust zone? Another question would be you have shown Vakrita thrust. Now, what is the nature of the Vakrita thrust? Is it a ductile thrust? Now, when you answer the second question, then I will have another counter question to you. So, please do answer my question, first two
Okay,
questions.
okay. So the thickness, the overall thickness that we could that we could measure through this mapping, it came out to be varying in all three valleys. Munshari thrust varies from somewhere 3.4 kilometer to 3.6 kilometers in all three valleys. But whereas the Vakrita thrust zone, when we talk about it, it shows a variable thickness from 2 kilometer in the Adiganga Valley to up to 5 or 6 kilometers in the Bhagirathi Valley. And That is based on the mapping that we have done, based on the identification of the damage zone and the shear zone pores in the region. We have calculated this thickness. Second, the nature of the Vakrita thrust. So to talk about the nature of the Vakrita thrust, as I pointed out, that this Vakrita thrust shows a variable surface manifestation. So it shows both brittle deformation. It also shows the ductile characteristics that depends on what level the Vakrita thrust is exposed and what sort of deformation has been there. So if we talk about the Bhagirathi Valley, it is essentially a ductile shear zone, as it is very clear from this photograph that these you see these asymmetrical quartz budines that basically got caught up along the shear zone and talk to the southwest directed asymmetric quartz budines and SC fabric within the Vakrita thrust shear zone, giving it a ductile behavior of the shear zone. On the other hand, when we look for the same fault, the same thrust in the Dhauliganga Valley, here we could identify that the same thrust zone appear as a brittle deformed fault gouge zone on the surface. And whereas in the Alaknanda Valley, it was very poorly exposed. So on that, we did for the strain analysis to identify the thrust. So
Okay,
it
so in the Dhauliganga Valley, the only criteria that you find for this Vakrita thrust is a gauge zone, isn't it?
sir, it also matches with the geochronological criteria, but we could not
No, no, that's
perform
fine. But
that is already structural
structurally the only criteria is the gauge zone.
Gaussian. Yes.
Okay, and in the Alaknanda Valley you did not find any.
In the Alaknanda Valley, the Vakrita thrust is not exposed on the
I mean, that
outward.
means you did not get any evidence or a Vakrita thrust in the Alaknanda Valley, isn't it?
No, based on the thin section analysis, we could identify a zone where maximum strain accumulation was observed. We systematically collected the samples right from the 1, 2, 3, 4, 5. So based on that, we saw that maximum strain accumulation was being observed along the this particular zone, which was well coincided with the previously reported location of the Vakrita thrust. So
No,
based on
what
that,
is
we have
this
said,
zone? Means is it between the higher Himalayan crystalline and the Munsheri formation?
yes, sir. This Selangkor is basically separates the higher Himalayas Joshimath formation from the lower Munchiari formation.
Okay, so that means from what I understood from your talk is that in the Dhauliganga Valley, the only criteria is the means you want to say that in the Dhauliganga Valley, the
Yes,
Vakrita thrust, possibly we are looking at the upper part of the Vakrita thrust where
yes,
there is dark
possible.
brittle deformation, and in the Bhagirathi Valley, possibly the deeper part is exposed. That's why we are finding some
Possible.
ductile behavior, isn't it?
This is one of the possibilities.
Isn't it?
Yes.
Okay, okay. But what is the means, topographic difference between this Bhagirathi Valley and the Dhauliganga Valley?
Uh, more
I
or
don't
less,
think that there is much of a difference. So to assume that Dhauliganga Valley is possibly an upper part of this thrust zone and the Bhagirathi Valley is possibly a deeper zone, it possibly it defies some logic here. And second thing is that whether it has struck in your mind that because you are not finding too much of an evidence for Vakrita thrust in both Dhauliganga Valley as well as in Dhauliganga Valley, that could be because of reactivation also, some fault gouging has happened. And in the Alaknanda Valley, you did not find any. Whereas in the Kumaon Himalaya also, several workers have said that they did not find any structural evidence for a Vakrita thrust.
yes,
So
sir.
possibly, I think you may relook at this particular Vakrita thrust, its deformational attributes, the strain accumulation, and the high strain zone that you were talking about. Possibly, I think you might have to have a relook considering the other work that people have done in the Kumaon Himalaya also, you must be open to the fact that Vakrita thrust, there might be some controversy regarding the existence of a Vakrita thrust.
Yes, sir. But whatever literature we have been seeing, that mostly it is said that Vakrita thrust represent the main central thrust. So that's the complexity in the region that to which thrust we should
Many
assign as
workers
the
have said that the
main
Munsheri
central
thrust is the main central
Exactly.
thrust.
Exactly.
So there lies several, means obviously the controversies are never ending, but you
Yes.
also must be open to the other school of thought also.
Yes.
Okay.
Yeah, we. Yes, sir. And actually, sir,
Okay.
why
Okay.
we
Thank
have.
you.
Okay.
Yes.
Arinanda,
We.
Arinanda,
Ah, hello.
yeah. I think the main controversy that revolves around this Honchiari and Vakrita is the inability to determine that which is display of which one.
Hmm.
That is the main
I
problem.
I I I would Shandeep.
Yeah.
So Shandeep, the problem is that if you go to the field and before starting the field work, if you keep in your mind that there are two thrusts, then
Mm-hmm.
possibly our eyes will try to look for two thrusts. Okay.
Yeah, definitely. That
So
is there.
the original definition for main central thrust has been it means if we don't go by Hyman Ganser, if we go for a structural definition for main central thrust, it's a shear zone. It's a zone of a strain accumulation, high strain accumulation. So
Exactly.
basically, obviously, and a shear zone is punctuated by the nature of the shear zone is so it is punctuated by several discrete smaller shear zones. The entire
Exactly.
all the shear zones make a big shear zone. Now the thing is that if you go somewhere and if you in the field, suppose to the south you are getting a shear zone, you mark it as Munsheri thrust, and suppose you are going towards north. Then again, you find a discrete shear zone, and then based on that, you mark another shear zone. So this will lead to endless shear zones within a
Now
very
this is never
small
end.
stretch.
That's why if you look carefully, not several, but a few authors have also said that there is a MCT zone. It's not like
Yeah,
only
that is what I
one.
am referring to. Yes,
Yeah,
yes,
one.
absolutely.
It's not like one thrust or one shear zone that are or two shear zones or two thrusts separated
Yeah,
by.
but the problem would be, Shandeep, the problem would be
Not like
if you
this.
start naming each discrete shear zone one a distinct thrust, then the problem would arise.
Exactly.
Yeah, that is what I was pointing to. Otherwise, it's a very good
Exactly.
work. Just I
Right.
had to get out some of my conclusion here. Yeah.
No, the data is really good, Rahul. You can also think in this way. This MCT zone, I think, if I
Actually,
can remember correctly, Professor Haribahadur Srivastav, he has
yeah.
done some work early in 2010, 2012, where he has referred it as MCT zone, not as a single one.
Yes, sir.
So he has demarcated
Actually,
this is Munchiari, this is Vakrita. He has also said the same
yes, sir.
nomenclature, but he was that there are several. From your block diagram also, you have also in your block diagram, if you,
Yes, sir.
this one itself means you have shown already that there are several
Yeah.
such zones. It's not a single zone. There are
Sir,
several
actually,
zones.
the whole idea started with the MCT zone only, but with due course of time and comments from the reviewers, we narrow it down to Munshari thrust zone and Vakrita thrust zone.
No, this is fine. This the block diagram, this is fine with me. There is no problem.
Yes,
If I say this whole zone is your MCT zone, then it is directly answering, I think, Arindam's question
yes,
that it's a zone.
Yes, yes.
Yeah.
Shandeep, here I would
Yeah.
like to say one thing.
Mhm.
Rahul, if you mark the entire
yes,
thing as a single zone, then there is no problem. But the thing is that within that zone, if you
yes,
find, suppose in an area you are finding some shearing evidences, ductile shearing evidences, the problem
hmm,
becomes when you try to name that particular zone as a distinct thrust.
exactly.
because if you go if you look at the piggyback model, so it is very difficult to localize two custom scale thrust at such a small distance. So if you can treat it as a single zone rather than two individual distinct thrusts, I think many of your further questions can be answered.
Right.
Yes,
Absolutely.
Thank you.
Okay, I think
Thank you,
Professor.
Rahul. I had this much of question. Thank you very much.
Okay, okay.
Thank you, sir.
Professor Subroto Ghosh sir has also
Yes, yes. Subrat sir, please go
Yes,
ahead.
raised
yes,
hand of queries, I think. Yeah, sir, go ahead, please.
Can you hear me,
yes,
Rahul?
sir. Yes, sir. Yes, sir.
Okay.
Sure.
Um, did I published one paper in Himalayan Geology in
Yes,
2019?
yes, sir. Yes, sir. I have
Did
seen
you
that. Yeah.
did you read that?
Yes, sir. I
The
have gone through that paper.
Yes, the preceding discussions by Sayandeep, by Arindam Babu, they also pointed to the advantage of considering the entire zone as a shear zone, thick shear zone,
Hmm.
with
Yes,
its
sir.
two boundaries, upper boundary and lower boundary.
Lower one.
I also
Yes.
try to consider it that way. You have a lot of data; those are very valuable things. But considering the large-scale framework, structural framework, um, uh, considering these individual discontinuities as separate thrusts would be rather difficult to reconcile in a large scale context. That is one thing.
Yes.
The other
Yes.
point that I would like to highlight is you mentioned that the Boikrita thrust is represented by brittle deformation features, particularly in the Thauliganga valley.
Horizontal.
So
Yes.
my first impression is that it could be very late structure. These fault, gauge zones, etc. That may be very late structures, developed much later than the original Boikrita thrust or the upper boundary of MCT zone. What is your take on that?
Uh, Sir, it is possible that these are the very late structure, but we are talking about the superficial expression. How should we identify? Then one thing we should be note that then why these type of late structures are occurring in that zone and they are coinciding with the Vakrita thrust. So
Yes,
possibly
the photograph
uh,
here looks like a kind of landslide, that kind of thing, a faulting gauge, very late.
yes, sir.
And it can, Arindam Babu also mentioned that it could be a reactivation kind of thing. It's
So,
after all
but
a deformed.
reactivation must also have taken place along the thrust only. So, because of that, on the surface it get exposed as a fault gouge zone. Otherwise, we do not see any other. And if we also combine these fault gouge zone along with the geochronology data on in this particular area, so on the northern side we have dated the rocks just in the immediate hanging wall side, and we see the Semitic gneisses that are present in the Joshimat rocks, Joshimat formation, they are Neoproterozoic in age. Whereas in the immediate footwall side, we have dated these quartzites and these Munshari group gneisses, they are Paleoproterozoic in age. Though I could not show that data, but because of that also we can say that there is a age discordance also across this fault gouge. So along with this appearance of this fault gouge in that region, we also see the almost a very significant age
Now,
discordance process.
now, now, could these inhomogeneous ages be not related to the involvement of different types of lithology of different times? Because particularly in the higher
Hmm.
Himalayan crystalline zone,
Yes,
there
sir.
are many later intrusives, and they could have
Uh,
intruded at different times. So the
so
samples that you
yes,
might
sir.
have used, maybe just by chance, maybe you
Uh,
took a relatively younger one, Neoproterozoic ones, whereas below the Boikrita thrust, you have taken slightly older ones. That could be a possibility, isn't it? Uh, because
Actually, so these rocks that we have dated, these are the country rocks that are present, and essentially in the entire stretch of the Greater Himalayan rocks, you will see only the inherited component in the zircon will be Paleoproterozoic, but the overall depositional age that we get, it is entirely Neoproterozoic, and it is well established in that region in the previous papers also, and same as
okay,
likewise in the Munshari group also.
now
Although we, as you're saying, it is correct that there are possible intrusions also. We have dated those intrusive bodies, and they came out to be Paleozoic or Cenozoic, which we do not see towards the footwall side.
uh, yes, man.
to us, sometimes the absolute ages are the most non-absolute things. There are so many factors that might influence those ages. That is what my feeling is, because so many things we cannot see, we cannot constrain those. So giving specific interpretation to a particular age would be rather, okay, that is at least my personal view. Okay.
So
And
that's why, sir, it is necessary to combine all different sorts of methodologies to look for a thrust. Like we need to combine the structural data along with geochronology data to, if we have to assign a thrust as MCT.
yes, I have been working on in the Garhwal Kumaon region.
Yes, sir.
To me, the MCT zone is okay. It's a kind of structural phases. All the structural associations, which the structure association of the structures which developed during the MCT emplacement, they together defined that zone. In certain cases, the stratigraphical inputs or stratigraphical features, in certain cases, metamorphic features, in certain cases, radiometric features, they just coincidentally accentuate it. But we cannot depend on those things, because MCT zone is all along the length of the Himalayas, and it cuts across the stratigraphical boundaries, cuts across lithological units. So all types of inputs are there within the MCT zone. So what defines the MCT zone is its particular association of structures which are not present above it and neither not present below it. So if we can recognize, that is my personal feeling is, I have been working in that area for a long time. And final one question, in the diagram, Professor Mukherjee et al.'s reference was there. In the diagram, you showed that the Munshiri was just above a subduction zone, and the subduction was going on southward, and the rift basin in which the Berinags were deposited, this one. So my straight question here would be, how would you correlate, or how would you relate this subduction with the Tethys ocean opening, Tethian ocean opening, and the Tethian subduction? That is my final question for the time. Do you follow what I mean?
You mean to ask how it is related to the Tethys subduction?
Yes.
During the Cenozoic that happened.
Paleoproterozoic Oro-Syrian magmatic arc. Apparently, this is your Munshiri group. And to the south of it is the Berinag, the lesser Himalayan formations in the basin. And to the west of the Munshiri group, there is a subduction zone, which is northward subduction, isn't it? This is southward subduction. This is southward subduction. Okay? In the Tethys Ocean, the ITS, the subduction is northward. Now, how would you correlate or relate this subduction with the Tethian subduction, with the Tethian ocean opening, etc.? That is my question. If you have thought about it.
We have not thought about it, but here, as we can see, this is the tectonic setup in the Paleoproterozoic time, and it is possibly the northward subduction that has been present, and it is when this entire Munshiri group, or the lesser then the present days lesser Himalaya or the greater Himalaya, even the Tethians were part of the active continental Indian continental margin during that time.
In this model, in this subduction, to the north or to the left of Munshiri group would lie a huge zone of crystalline rocks, high-grade crystalline rocks, which is the higher Himalayan crystallines. So where are they? Where were they located during this subduction? That is my question.
Sir, as per we talk about those higher Himalayan rocks, so their age has been reported to be Neoproterozoic, and these Munshiri group rocks are reported to be Paleoproterozoic. So what I have read from the literature, I know that these higher Himalayan crystalines were not the part of the Indian cratonic portion. They have migrated or they have transported somewhere from the onboard Arabian Nubian Shield, possibly because they show similar ages like that.
Uh, yes. Anyway, we can discuss later on. To
So
me,
if you
Very good.
okay,
I think he is referring that this is not the Tethian subduction that you were referring to. This is
yeah,
much earlier.
time relation between the two, how the Tethys option would occur after this within, and that time is not a long gap because Tethyan
yes,
Ocean
Okay.
opened, or drifting of Tethyan Ocean was
mhm,
not okay much later than the
much later.
not much later than this subduction shown here. So how they correlate or how they are related in time, that is my question. Anyway, you did a lot of work.
I'll yes, sir.
Yeah, I think Rahul will look into it.
Yes, sir.
Yeah.
Okay. All the best, Rahul. Thank you. Thank you. And
Thank you, sir.
we'll
Thank you.
get in touch with you later.
Sure, sure.
Any more
Right,
questions?
Arun.
Yes.
So, means as there are no other members present, so
Yeah.
uh, as a member of the council member, I'd like to thank Rahul, Dr. Rahul Dixit,
Thank
uh,
you, sir.
and I think he has been awarded with a PhD this year only.
Yes, sir. Recently,
Right,
few
Rahul?
months.
Yeah. And he has three mentors, as far as I know, three
Yes.
generations of mentor, starting from Professor A.K. Jain, followed by Professor D.C. Srivastava, and again finally Professor Sudhir Kumar Tiwari.
Yes, sir.
So I
Yes.
think he has been trained well and he will do fabulous work in the years to come because this is his start of his early career because as he has finished his PhD. And thank you, Rahul, for taking your time from your schedule to answer our call from our group, and I would urge you to become a member. It's actually free registration, so you can become a member anytime you want. And
Yeah,
also
sure.
encourage your students, be it your MSc students or be it your future PhD students, to get yourselves registered to
Sure.
our on behalf of the community and on my behalf. I would like to thank you again for your time. Thank you, Rahul.
Thank you, sir. It was my pleasure to present my work here with you all. Thank you.
Thank you, Rahul. I think we should conclude this. Thank you.
Okay.
Have a nice weekend, all.
Can we disconnect it now?
Yes, please.
Yeah.
Thank you. Thank you.
चोरी चोरी मिले थे जिस जगह
Ironland in those events, but it was not enough. The gold went to a monster toss from Kildonian Empire. There was also a 100-yard dash, breakdancing. Because some micronations only have one delegate, most of the sports have to be solo, which is kind of like how the big Olympics tries to be fair by not having football or cricket. But the event that Ironland took home the gold medal in was trivia. Some people will say that's not a real sport, but Ireland citizens vote in the comments yes or no whether you think trivia should be recognized as a sport in our micronation. I am proud to announce that हमारा नाम हारून शाह अली बेग है। हमारी मर्जी के बगैर कोई हमको छूता नहीं। हटाओ इसे। तुम कल ऑफिस नहीं जाओगे ना, तुम आज जाओगे अभी। बहुत सही है सर, इसका जवाब तो देना चाहिए। ये पूरे डिपार्टमेंट के मुंह पे तमाचा है। अब ऑर्डर करिए, इस बार या वो नहीं या हम नहीं। बात यार कितना सबको हॉलिक में लगा दो। तुम्हारा दिमाग तो ठिकाने पर है। गलत कर रहे हो दिमाग, पागलपन है, इसको बंद कर दीजिए। और जब तक मेरा दूसरा ऑर्डर नहीं आ जाता, तब तक कोई ऐसा गलत कदम मत उठा लेना। बात तो सुनो, रात उठा आओ सर। हमारा नाम हारून शाह अली बेग है। हमारी मर्जी के बगैर कोई हमको छूता नहीं है। पढ़े लिखे हो ना, हटाओ इसे। लीबिया के रेगिस्तान में खाना उगाने की उम्मीद किसी को नहीं थी। कुछ लोग इसे चमत्कार कहते हैं। अब्दुल्ला अल फहानी मैग्नेट में पोल नहीं होते हैं, ना नॉर्थ पोल होता है ना साउथ पोल होता है। पोल नाम की कोई चीज नहीं होती है। वो सबके सब आयरन के एटम्स हैं। सबके सब जो है इलेक्ट्रॉन्स, प्रोटॉन्स और न्यूट्रॉन्स के समूह हैं। सबकी जो रचना
डिस्ट्रीब्यूशन है, कॉन्फ़िगरेशन है इलेक्ट्रॉन का, वो सबका आइडेंटिकल है। जब आप उसको मैग्नेट बनाते हो तो कोई नया पोल वहां पर पोल नाम की चीज अलग अलग किस्म की चीज नहीं डालते हो, और किनारों से थोड़ा अंदर हटकर कुछ नहीं होता भैया, जैसा किनारों पर है वैसा ही हर क्रॉस सेक्शन पर आइडेंटिकल है। इज नथिंग लाइक कि किनारों से थोड़ा अंदर घुस के कोई खास चीज है जहां से कि मैग्नेटिक फील्ड लाइन जनरेट हो रही है।
First day in Europe. Europe. The country where it all began. So nice to be in a place that still feels civilized. Screw the American charade. They can clean up their own mess. 1 week in Europe. I can't believe my grandfather moved to America for a better life. It's so much nicer here. 1 month in Europe. Thanks. Jesus, really? Why are the portion sizes here always so small? I'm still gonna be hungry after this. At least people won't call me gay for reading a book in public. 1 year in Europe. Dude, you gotta come to Europe, man. People actually live a life outside of work here. Yeah, you get paid less, of course, but at least your taxes are going to something. I can even go to the bathroom at work without asking anyone. I feel like a human being again. I'm losing weight. I'm not even trying. 5 years in Europe. Hey, waiter, can I get some ranch dressing, please? Americans are flocking to Europe. Now I'm gonna rid this continent too. I came here for peace. 10 years in Europe. Hey, you're the comedian, right? You're an American as well. High five. I'm here with your passport now. I prefer to shake hands. Oh, come on, man. Once American, always American. You want some ketchup too? No, I've had enough of immigrants like you. I fled a bit.
कॉमेडी स्टार कपिल शर्मा काफी टाइम से वो अपने ट्रांसफॉर्मेशन को लेकर चर्चा में है। कपिल के फिटनेस कोच हैं योगेश भटेजा। योगेश ने बताया कि कपिल ने वजन घटाने के लिए 21-21-21 रूल फॉलो किया है। अब ये 21-21-21 रूल क्या है, ये हमने पूछा नोएडा में डेली डाइट्स की फाउंडर और डाइटिशियन अमृता मिश्रा से। डाइटिशियन अमृता बताती हैं कि 21-21-21 रूल के शुरुआत के 21 दिनों में मूवमेंट पर फोकस किया जाता है, यानी स्ट्रेचिंग करनी है, एक्सरसाइज करनी है, चलना फिरना है। जिम में पसीना बहाना जरूरी नहीं है, पर सुस्ती पूरी तरह छोड़ देनी है। जब 21 दिन बीत जाते हैं तो अगले 21 दिन खाने पीने में बदलाव किए जाते हैं, जैसे चाय में चीनी कम करनी है, मीठा एकदम कम कर देना है, तली भुनी मसालेदार चीजों से दूरी बना लेनी है, खाने का टाइम ठीक करना है। बहुत स्ट्रिक्ट डाइट फॉलो नहीं करनी है, लेकिन खान पान को हेल्दी बनाने के बदलाव करने हैं। अब आखिरी 21 दिन क्या करना है, इसमें आपको वो चीजें छोड़नी है जो आपको कोई फायदा नहीं पहुंचा रही हैं, जैसे सिगरेट, शराब, चाय, चिप्स, आइसक्रीम वगैरह।
I don't think you get the sense.
It's not looking too good. What'd you just do to me? That's lithium dioxide. It's gonna take the edge off. Trying to get you back to work.
Trust me, I know I'm good at this stuff. I've been looking for a suitable replacement for the Palladium Life Track. Every combination, every permutation of every known element.
Well, I'm here to tell you, you haven't tried them all.
George, can you kindly vacuum fermentation wireframe? I need a manipulable projection. What does that look like to you, Jarvis? Not unlike anatomy.
What is it you're trying to achieve, sir?
I'm discovering, correction, the structure of the protons and the neutrons. Missing the pavilions. Dead for almost 20 years, still taking me to school.
The proposed element should serve as a viable replacement for palladium.
Thanks, Dan. Not looking for.
Let's explore how the famous roux porcelain is made, a delicate craft passed down for centuries. We start by picking smooth white stones, agate, and calcine them at around 1200 degrees Celsius so they become easy to crush. The stones are ground into a fine powder using a special stone grinder called a libo. Water is added to the powder, and it's mixed with a stick into a smooth pulp. This is left to settle. Next, wood, especially chestnut wood, is burned to create ash. The ash is filtered, soaked, and rinsed several times to remove any alkalinity. This is left to settle. Again, we collect the fine paste that settles at the bottom. Both the agate paste and wood ash paste are then dehydrated a bit and left to age. This gives them the perfect texture for shaping. Now the real artistry begins. The clay is shaped into cups on a potter's wheel, carefully trimmed and left to dry halfway. These pieces are then fired at about 800 degrees Celsius to strengthen them and make them ready for glazing. To make the glaze, we mix the agate powder, wood ash, feldspar, and a golden colored soil. The fired cups are cleaned, dipped into the glaze mixture, and left to dry. Finally, they're fired again at high heat in a charcoal kiln. And there you have it, a gorgeous piece of Rue porcelain, crafted with skill, patience, and tradition.
वेस्ट बंगाल से ना काफी ज्यादा शॉकिंग डेटा सामने आया है एंड इस डेटा के हिसाब से वेस्ट बंगाल से जो है 6,688 कंपनीज शिफ्ट कर चुकी है मतलब इन हजारों कंपनीज ने अपने प्रोडक्शन वेस्ट बंगाल में बंद करके देश के बाकी स्टेट में शिफ्ट कर दिया है मतलब ये सिर्फ एक कंपनीज का लॉस नहीं है वेस्ट बंगाल के लिए बल्कि लाखों नौकरियों का भी एक लॉस है जो ये शो करता है कि वेस्ट बंगाल जो है वो इंडस्ट्रियल कोलैप्स की तरफ बढ़ रहा है एंड मेनली जो ये सिचुएशन है वो क्रिएट होती है पॉलिसी इंस्टेबिलिटी एंड बैड गवर्नेंस के चलते पुलिस ज्यादातर जो कंपनीज है वो महाराष्ट्र में दिल्ली में उत्तर प्रदेश में और अलग अलग देश के हिस्सों में शिफ्ट हो चुकी है इसमें नंबर 1 पे है महाराष्ट्र जहाँ पे लगभग 1308 कंपनीज वेस्ट बंगाल से शिफ्ट हुई है उसके बाद है दिल्ली जहाँ पे 1297 कंपनीज जो है वेस्ट बंगाल से शिफ्ट होके आई है थर्ड नंबर पे यहाँ पे है उत्तर प्रदेश जहाँ पे आप ओह माय गॉड रेडी कस्टम्स के स्टॉल पर अगर आप आएंगे तो यहाँ पर फोर्थ अर्मेनिया खड़ी है अब ऑब्वियसली बात है काफी हाईली कस्टमाइज्ड है जैसे ही आप इसे ओपन करते हैं तो यहाँ से कुछ स्टेप्स बाहर की तरफ आ जाते हैं और आप इस तरीके से अंदर जा सकते हैं अंदर जाते ही सबसे पहले तो यहाँ पर इंटीरियर देखो भाई क्या प्रीमियम नजर आता है और यहाँ पर दिया गया है वॉशरूम अगर आप देख रहे हैं यहाँ वॉशरूम में आप नहा सकते हैं और फ्रेश वगैरह हो सकते हैं इसके अलावा यहाँ पर कॉफी मशीन है यहाँ टीवी मिल जाती है ऊपर की तरफ ओवन मिल जाता है यहाँ पर ट्रे मिल जाती है और सारी चीजें जितनी भी चीजें हैं वो आप यहाँ से कंट्रोल कर सकते हैं चाहे आप इसका कर्टेन ओपन करें या कुछ भी करें वो आपको सब यहीं से ही देखने को मिल जाता है कैप्टन सीट्स हैं और बहुत ही ज्यादा आरामदायक हैं अब यहाँ पर अगर आप बैठेंगे तो यहाँ पर प्ले स्टेशन भी दिया है और यहाँ से आप इजिली गेम वगैरह खेल सकते हैं और टीवी वगैरह में यहाँ पर एक आपको फोन दे दिया है इसके अलावा यहाँ पर अंदर की तरफ ट्रेस वगैरह देखने को मिल जाती है जो कि आप देख सकते हैं यहाँ बैठेंगे छोटा सा मिनी बार है दारू की बोतल रखी है 4 ग्लास रखे हैं और जो फोर्थ अर्मेनिया है उसमें एसी आता है बीच की तरफ यहाँ दे दिया है पीछे एम्बिएंट लाइटिंग बहुत ही जबरदस्त कर दी है इसके अलावा कहानी यहाँ खत्म नहीं है ऊपर की तरफ अगर आप आते हैं तो प्रॉपर यहाँ पर बेड दे दिया है तो आप आराम से ऊपर चढ़ के सो सकते हैं और ऊपर चढ़ने के लिए स्टेयर्स आपको यहाँ पर देखने को मिलती है अब अर्मेनिया को अंदर से ही हाईली कस्टमाइज नहीं किया गया बाहर से भी आप देखेंगे तो इसका जो लुक है वो पूरी तरह बदल दिया है और इस पूरे कस्टमाइजेशन के लिए आपको सिर्फ देने होंगे 15 लाख रुपए कस्टम्स के स्टोर पर अगर आप आएंगे तो यहाँ पर फोर्थ अर्मेनिया खड़ी है
Throwing away or spent batteries. First of all, you shouldn't be throwing them into the trash to begin with. They're meant to be taken to battery recyclers, but you can avoid even that with these USB-C rechargeable double A's. We've come a long way since the low capacity pack of rechargeable cells you'd always forget to plug into the funky dock on the wall. I just picked up these 3,600 milliwatt hour double A's, and they literally all just have USB-C ports on the sides. They have a capacity and voltage on par with most non-rechargeable batteries at the same size, and they even come with a 4-way octopus charger to keep the 4-pack juiced up. The ones I got were $19 and promise 1,200 charging cycles, meaning if you don't lose any of the things, you're effectively getting 4,800 as long as you're cool with only using 4 at a time. This thing would kill that game was popular.
कितने साल से दंगल करा रहे हैं 5 और कितने लोग आते हैं हमारे दंगल देखने मुट्ठी भर जिस शहर में आज तक छोरी को लड़ते भी नहीं देखा उस शहर में छोरी छोरी से लड़ने में खाने में उतरे तो कितने लोग दंगल निकल जाएगा हमारा छोरी के हाथ में टूट के तो टूट नहीं तो रुपए मिलेगा ना टिकट के तो भी तेरे पहलवान महीने भर बैठ के खाएंगे मैं पहलवान को शेर से ब्लेड बताना तो भी तेरे को नहीं आता तो कितने सेकंड टिकट जब तक तू बोलेगा तब तक तो ठीक हो जाएगा लेकिन किसी ना फट जावे और फट जावे यार
दंगा के मुझे आती है तो चुन ले किसने आना है
उसकी लस्सी बनाऊंगा।
अभी ये तेरी छोरी अपनी जेब में, वरना सिंगल पीस में वापस आ जाएगी। दंगल लड़ने से पहले डर से लड़ना पड़ता है। तो मेरी छोरी डर से तो जीत गई।
कितने साल से दंगल?
जिंदगी
आज हम जा रहे हैं 3,000 की गुजराती थाली खाने के लिए एट द हाउस ऑफ एमसी। तो ये वही जगह जब जापान के प्राइम मिनिस्टर यहाँ पे आए थे तो मोदी जी उनको वहीं पे रेस्टोरेंट डिनर के लिए ले गए थे। यहाँ पे गांधी जी ने भी स्टे कर काफी हेरिटेज प्रॉपर्टी, कम से कम इनका कई 100 साल का इतिहास चलती है और यहाँ पे ये थाली इंजॉय करते हैं।
ये पहला होटल है जहाँ पे पॉज एंड देन यू कैन ईट।
तो यहाँ पे जितनी भी रेसिपीज वो काफी पुरानी है। जो गुजराती खाना होता है वो मीठा होता है। पहले जमाने में काफी गर्मी होती थी तो मीठा एज अ ग्लूकोज काम करता फॉर इंस्टेंट एनर्जी। तो मैं ये सपोज करूँ कि पुराना खाना है तो मोस्टली ऑफ फूड वुड बी स्वीट। तो हमने बात बोली, सबसे पहले सर्व होता है पपाया नींबू का शरबत, यानी पपाया एंड नींबू का शरबत काफी टेस्टी है। पहली बार ये शरबत पी और मुझे काफी अच्छा लगा। उसके बाद सर्व होता है, इन्होंने लिखा है सफेद ढोकला, बिकॉज टूरिस्ट यहाँ पे काफी आते हैं, लेकिन जो सफेद होता है वही ढोकला होता है। पीने वाला खमन होता है। इट्स मेड ऑफ सिल्वर। तो दिस इज द मोस्ट एक्सपेंसिव थाली दे है। ये भी चांदी का ग्लास है। दिस इज ढोकला, जो राइस से बनता है। नेक्स्ट इज कोरिएंडर पीनट चटनी, फिर खजूर अमली मीठी चटनी हमने ली इसके साथ में। ढोकला काफी टेस्टी था और फ्रेशली मेड। फिर हमने हांडवो देखा, हांडवो भी उन्होंने स्टीम करके एक साइड से ग्रिल करा था, काफी अच्छी प्रेजेंटेशन थी। फिर आए पापड़ एंड उसके एक सैलेड सर्व करा व्हिच वाज कैप्सिकम राजमा टमाटर का सैलेड। इट वाज वेरी नाइसली डन। फिर हमने सर्व करा मिर्ची वड़ा व्हिच वाज वेरी डिलीशियस, काफी टेस्टी था ये। एंड दिस इज द दही वड़ा, काफी अच्छी इसकी सीजनिंग हो रखी थी। छाछ थी, बिकॉज गुजराती फूड विदाउट छाछ इज इनकम्प्लीट। फिर सब्जियों में जो हमने खाया वो था पालक जामुन की सब्जी, जो बेसन के पकौड़े टाइप पालक के होते हैं। देसी चना था। फिर दाल सिंह वाला बताका, मसाला टिंडो, ये टिंडे की जो सब्जी थी। देन फुल्का रोटी थी, साला पराठा था, गुजराती दाल थी, गुजराती कढ़ी खाते पहले, जामुन पालक, फिर एक खिचड़ी। ये है मोदक गुजरात हल्के से जरा से क्या डाला नेक्स्ट चीज हम जो टेस्ट करेंगे वो बासुंदी। बासुंदी क्या होती है मुझे पता, रबड़ी होती है बट इट्स अ मोर लिक्विड फॉर्म, सो कम काढ़ा जाता है। दैट्स बासुंदी फॉर यू। अब आई डिजर्ट की बात है तो खाना काफी स्वीट था। अब मेरा तो स्वीट पैलेट काफी खाना है तो इट वाज डिफिकल्ट फॉर मी टू ईट। तो पंपकिन हलवो यानी कद्दू का हलवा एंड ट्रस्ट मी ये हलवा काफी टेस्टी था। फिर है श्रीखंड। मतलब आप मान लो जितनी सब्जियां है उतनी ही आपके पास डिजर्ट है। अच्छा ठीक है। तो राजा महाराजा के स्टाइल है। अच्छा एंड देन ये सर्व करते हैं आइसक्रीम व्हिच इज इन हाउस मेड। आइसक्रीम काफी अच्छी थी। एंड में आपका ऑप्शन होती है टी या कॉफी लेने की। हमने एस्प्रेसो शॉट किया व्हिच वाज मतलब इन यूजू हेरिटेज एंड स्टोरी है एंड रेसिपी है हिस्ट्री है। आई थिंक डेट हमारे पास जो चीजें हैं उसमें सिर्फ चीप लेबर ही बचा है और वो फूड प्राइसेस ऊपर जा रहा है तो वो लेबर चीप रहा नहीं है। The Bengaluru builder has done something really smart here. He hasn't used even 1 kilogram of cement in this house. Instead, he built the entire structure using an interlocking mechanism. Let me explain. Think of the old temples in India. They were built using rock-on-rock structures where every block was carved and placed with such precision. They didn't need cement to hold them together. No steel, no concrete, just engineering brilliance that stood for centuries. That's exactly what this builder did. Each block here locks into the next like a 3D puzzle, making the structure stronger over time, not weaker. Now, where a regular concrete house has a lifespan of around 100 years, this house has a projected life of over 1,000 years, which is basically close to infinity. Comment rock and I'll send you a guide on how you can build a cement-free home like this. Be broker responsibly. Bengaluru builder has done something really smart here. He hasn't used even 1 kilogram of cement in this house. Instead, welcome to the Alien official.
Apparently, you can tell Kane Stokes' birthday joke. Hey, what are you doing, man? Oh, it's true. This is plastic. It goes in the other thing. I forgot it. No, man. This is money. Literally money. Money? 1 week in Germany. Oh, wow. There is actually a 25-cent deposit on dollars here. So they charge me this, and then I have to go back to the supermarket to get my money. That's crazy. 1 month in Germany. Actually, this makes so much sense. It makes people responsible for their garbage, so they don't throw it everywhere. This is genius. finish for that? No, there's still something in there. Hey, what the hell? Now it's empty. This is the easiest money ever.
मेरा नाम अफसर अहमद कुरैशी है। मैं रियासत महमूदाबाद से 12 साल की एज से जुड़ा हुआ। इसके पहले हमारे दादा ग्रैंडफादर जो थे वो राजा अमीर अब्दुल्ला साहब और महाराजा साहब के जमाने से यहाँ करीब 24 बावर्चियों का यहाँ स्टाफ यहाँ के बावर्ची खाने में, जिसमें कुछ चीजें हमारे दादा की बहुत स्पेशल। शाही टुकड़ा यहाँ का जो है वो बिल्कुल अलग और मुंह में रखते हुए बिल्कुल मलाई की तरीके से होना चाहिए और उसमें ड्राई फ्रूट वगैरह आप लोग नहीं यूज करते हैं, सिर्फ मलाई और दूध और घी और ब्रेड और जाफरान। पुराने जमाने में जितने कलर बिरयानी में और पुलाव में यूज हो रहे हैं सब जाफरान, उसमें कलर तो आता था लेकिन जो खुशबू होती थी दो दिनों तक के लोगों के जो जहन में बसी रहती थी। सन 1982 में राजा साहब ने महमूदाबाद के किले में एक दावत दी, तो राजा साहब ने दादा को बुलवाया वहां, तो कहने लगे कि ये हुनर तो करीब समझिए कि जा रहा है, तो यहाँ की चीजें हैं किसी को दिखाएं। दादा से कि आप ये तो बोलते हैं उनको सिखाइए और जो हो सकेगा मैं इनके लिए करूंगा। तो मैं उनके साथ जाता रहा, फिर धीरे धीरे करके करीब 90 तक की हमें काम पूरा आ गया। मेरा नाम अफसर है।
It's about one drop is left. Not the sample for perfume, but the problem is when I went to buy it, it's $2,000.
Yeah, it's very expensive. Can I try?
Yeah, sure, but it's only one drop left.
That's okay, no problem.
I cannot afford 2,000. Can you make it for me?
Sure.
There is cardamom, cinnamon, patchouli.
Getting all that from
Yes, black pepper, saffron, cedarwood, many nuts is there.
Palo Santo.
Yes. You can check the same.
But Yusufa, it's not the same brand.
Are you sure?
It's much better.
People say I ruined my house. Here's how. I got these crazy high ceilings with these beautiful windows, and I made a duct tape hammock to look out the windows. I don't know what I thought was going to happen. So hammocks aren't made out of duct tape. They're made out of rope. So I threaded rope in the reinforced walls so that I could thread between that a hammock, a whole level above the stairs, hand woven. It's done. How do you get up to that level? Portals. It overlooks the stairs, but we want another level so we could really hang out at those windows. It's all hand woven and tight, so the level is actually bouncy like a trampoline. Cool designs like ladders and teepees. These tubes are about to become a slide, and it looks like a treehouse in the sky. We had a ladder so that kids can get up there, and now it's time to show my kids their new play place above the stairs. People think I ruined my home value putting this in. What do you think? Hey, no peeking to you either. Run up and clean it.
Count up three. Count up three.
1, 2, 3. Look up.
People say I. ये है इंडिया का एक ऐसा गांव जहां इंडियंस नहीं बल्कि फॉरेनर्स रहते हैं। तो आज मैं आया था धर्मकोट में, जो कि हिमाचल प्रदेश की धर्मशाला में है। यहाँ आके आपको ऐसा लगेगा कि आप बिना वीजा के कोई दूसरी कंट्री घूम रहे हो, जहाँ आपको दुनिया की हर एक कंट्री का इंसान मिल जाएगा। ये जिनके ऑनर खुद फॉरेनर्स है, स्टे यहाँ घूम कर मेरी एक नई दोस्त भी बन गई। कैटरीना रशिया से है, जो कि 12 साल से पूरी दुनिया अकेले घूम रही है। फिर कैटरीना मुझे अपने साथ ले गई इस विलेज को एक्सप्लोर कराने। क्या मजेदार बात है ना, मैं खुद इंडिया में हूँ और मुझे यहाँ पर एक फॉरेनर गाइड कर रही है। कुछ देर घूमने के बाद हम एक कैफे में गए, जहाँ पर हमने काफी टेस्टी इंडियन खाना खाया। फिर कैटरीना अपने आने वाले ब्लॉग्स में कवर करने वाला हूँ। ये है इंडिया। आप सुबह जब हिमाचल
घूमने निकला तो कुछ देर बाद लगा कि अरे ये मैं थाईलैंड में कैसे आ गया। नमस्कार दोस्तों, मेरा नाम है तुष्की। मैं पिछले 2 दिनों से रुका हुआ था इस गांव में, और आपको याद है ना, यहाँ पर मेरी एक नई दोस्त भी बनी थी, जिससे अलविदा कहकर मैं पहुंच गया ये बस चाहता है। चलो 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 हाँ, मैं जा रहा हूँ धर्मशाला। उससे पहले आप ये बस देख लो, बचपन से ही मुझे बसेस बहुत ज्यादा पसंद है। अब लग रहा है ना कि मैं हिमाचल में घूम रहा हूँ। मैं फॉरेनर्स के साथ बेहतर भी ठीक था, पर ये वो एक्चुअल हिमाचल है जिसे देख कर मैं बड़ा हुआ हूँ। तो यहाँ पर स्पेशली मैं एक मॉनेस्ट्री में आया था, द ग्रेट बुद्धा स्टैचू देखने, जिसे देख के जनरली मुझे लगा कि मैं थाईलैंड में हूँ। ऐसा क्यों? एक भी स्मार्ट व्यक्ति की कमेंट में बता सकता है। ये है इंडिया का एक ऐसा गांव जहाँ इंडियंस नहीं बल्कि फॉरेनर्स रहते हैं। मम्मी ने भाभी का ऐसा गिफ्ट मंगवाया जिससे हर कोई बिना मेहनत के कुछ भी बना सकता है। तो इसमें देखा मम्मी कहीं जा रही थी, मैंने गिफ्ट तो देख जो आपने मंगवाया, बोले जल्दी दिखा दे, हमने दिखवाने जाना है। क्विकली इसे ओपन किया और ये मैजिकल अप्लायंस बाहर निकाला, इसके साथ स्पून, स्पैचुला, स्टीमर सब आता है। सिखाऊं मैं आपको ये? बोली प्रिया जी पता मैं तो जाऊंगा। हमने इसमें कढ़ाई पनीर बनाने का सोचा और इसको फैमिली अकॉर्डिंग सेट किया। भाभी को बताया इसमें सारे कुजीन बन सकते हैं, 500 प्लस रेसिपीज है, और अगर यूट्यूब से किसी रेसिपी का लिंक यहाँ पेस्ट करोगे ये वो भी बना देगा। और हमें तो आज इससे कढ़ाई पनीर बनवाना, शुरुआती पनीर मैरिनेट करने से इसने जैसे कहा उतना ऑयल, जैसे बताया वैसे प्याज बड़े पीसेस में काट दिया, स्केल पे मेजर करके डाले, और ये अप्लायंस एयर असिस्टेंट ईटिंग, चॉपिंग, स्टरिंग सब खुद करेगा। अब वापस 17 मिनट आप मस्त फोन चलाओ, ये तो खुद चलेगा। फिर मसाला पनीर पानी जो इसने बताया वैसे डाला, ये वाला साफ पनीर तैयार है। इधर रोटी बनी, फिर हम सबने खाया, और जनरली इसका टेस्ट जैसे किसी शेफ ने घर पे आके को बनाया। राधे राधे। मैंने भाभी का ऐसा गिफ्ट मंगवाया इससे हर कोई बिना। This is Europe's highest selling mattress, and this is now in India. Dad, what's wrong with her? I challenged her to get to 100,000 steps a week. That's so easy. Wait, that's something. I get a challenge. 99,999. She did it. Hey, Florian, I downloaded your My Step Counter data onto my computer, and make sure your path this morning was the same where my mom took in her race. So I'm basically just your step counter mule. I was never going to get 100,000 steps. But then I learned that there was going on a turkey. The second time I hugged her, it was a little harder because she was really wet. And I didn't care about my race. I love you very much, Claire, but your exercise doesn't really interest. Hang on, well, ये वीडियो है लंदन की। इस वीडियो में 15 करोड़ की बुगाटी वेरॉन आती है और ठीक उसके बगल में खड़ी होती है दुनिया की सबसे एक्सक्लूसिव रोल्स रॉयस। नाम है लारोस क्वाड्रप्टे। ये सिर्फ रेयर नहीं, सिर्फ एक ही है। जी हाँ, पूरी दुनिया में इस जैसा सिर्फ एक ही रोल्स रॉयस बनी है, और बनी है एक फ्रेंच बिलियनर कपल के लिए। ये गाड़ी इतनी महंगी है कि इतने में आप 50 रेंज रोवर्स ले सकते हो और 50 जी वैगन भी ले सकते हो, क्योंकि प्राइस है 260 करोड़ रुपए। ये कोचबिल्ट रोल्स रॉयस है, यानी पूरी गाड़ी कस्टम बनाई गई है एक सिंगल क्लाइंट के लिए। इसे बनाने में लगे 4.5 साल, और टोटल सिर्फ 4 ऐसी गाड़ियां बनी है। सबका नाम और थीम अलग होगा। सबसे पहला है लारोस नोवा, जो आप स्क्रीन पर देख रहे हो। दूसरी है एमेथिस्ट प्रोटे, तीसरी है एर्केडिया ट्रोटे, और चौथी अब तक सीक्रेट है। पेंट का नाम ही है टोलर। इंस्पिरेशन लिया गया है ब्लैक बकारा रोजेस से। इस पेंट को बनाने के लिए 150 अलग ट्रायल्स हुए, तब जाके रोल्स रॉयस ने स्पेशल रेड कलर डेवलप किया है। ये कलर स्पेशल इसलिए है क्योंकि अलग अलग एंगल से देखने पर कलर चेंज होता है, जैसे ब्लैक बकारा रोजेस। इस प्रोजेक्ट के लिए रोल्स रॉयस ने कई सारे कोलैबोरेशंस किए, जैसे सीना मारिया एगल, जिन्होंने इंटीरियर का एब्स्ट्रैक्ट रोज पैटर्न क्राफ्ट किया। एक सिंगल कारीगर जिसने 1603 पीसेस ऑफ ब्लैक स्कम और वुड को हैंडक्राफ्ट किया अपने हाथों से कंप्लीट साइलेंस में। ऑडिमार पिके, जिन्होंने बनाई 4 करोड़ की रॉयल ऑफ वॉच, जो डैशबोर्ड से निकाल के हाथ में पहनी जा सकती है। इस गाड़ी की ग्लास हो इलेक्ट्रोक्रॉमिक है, बटन दबाओ और डिसाइड करो सनलाइट कितनी अंदर आनी चाहिए। और रोल्स रॉयस ने कार का मोड मैच करने के लिए कस्टम शैंपेन बॉटल भी बनवाई। इंजन आता है 6.75 लीटर V12 ट्विन टर्बो इंजन, जो प्रोड्यूस करता है 563 हॉर्स पावर। ये रोल्स रॉयस सिर्फ एक कार नहीं है, एक लव स्टोरी है जो 260 करोड़ रुपए में लिखी गई है। अब बताओ,
सुप्रीम कोर्ट ने अभी हाल में 3 ऐसे फैसले दिए जिनसे लगता है कि अब शायद हम मर्दों को रिलीफ मिल सकता है। पहले केस में सुप्रीम कोर्ट ने बोला कि 498 यानी डोमेस्टिक वायलेंस, जब कोई महिला अपने पति के खिलाफ कोई एफआईआर करती है घरेलू हिंसा की, तो उसमें अरेस्ट नहीं हो सकती 2 महीने तक, और काउंसलिंग होनी चाहिए फैमिली। दूसरे केस में आईपीएस शिवांगी गोयल मैम का केस। ये केस काफी चर्चा में रहा क्योंकि आईपीएस शिवांगी गोयल मैम जब यूपीएससी का एग्जाम क्लियर की थी, उस समय ये एक सिंगल मदर थी, अपने बेटी को पाल रही थी, 2 बार सेलेक्ट नहीं हुई थी, और अपने ससुराली जनों की प्रताड़ना झेली थी। उसके बाद ये इन्होंने एग्जाम निकाला, 157 की रैंक आई। इसके बाद सारे केसेस होते हैं, केसेस यूपी अदालतों में कई सारे केस फाइल हुए थे। इसके बाद सुप्रीम कोर्ट ने बोला आज कि आपने जो झूठे मुकदमे फाइल किए हुए अपने पति के खिलाफ, आपको माफी मांगनी पड़ेगी, और सोशल मीडिया पे, इंस्टाग्राम पे, फेसबुक पे, ट्विटर, एक्स, हर जगह पे लिखना पड़ेगा कि सुप्रीम कोर्ट ने मुझे बोला माफी मांगने को, इसलिए माफी मांग रही हूं मैं, और इस सारे मुकदमे गलत थे, झूठे थे, जो सब हम आए। तीसरे केस में सुप्रीम कोर्ट ने बोला कि एक महिला को BMW कार, 12 करोड़ रुपए
तो अब इन फैक्टरों से लग रहा है कि हाँ हम शायद अभी आज हम आपको लेकर आए हैं कि चिकन रोड कोई और के
आज खाने में नहीं हो गया रे वही तो हर रोज होता है क्या अंकल कुछ पूरे स्पेशल रखा करो रोज वही खा के कैंटर के
व्हाट टू डू सर ज्यादातर कस्टमर उधार खाने वाले होते हैं कुछ तो ऐसे है जो फ्री में खाना खाने का
हाँ जैसे विजय
मैं उधार भी देने वालों में से नहीं हर हफ्ते हिसाब चुका हूँ
इसका मतलब अंकल मुझे ताना
मैं ऐसे ही बोल रहा हूँ
नहीं आज तुम्हारा हिसाब भी चुकता था हमेशा पैसा क्या करोगे इतने पैसे
दिनों में थोड़ी स्पेशल करो
कितनी उधारी बाकी
अरे जाने दीजिए सर जाने अरे ले लो अंकल जब पुलिस वाला पैसा दे रहा हो तो फटाफट ले लेना चाहिए
कितनी बात है बोलो बोलो शर्मा
3,542
3,542 कोई याद
सब तो मैं लिख के रखता हूँ ना
हाँ ठीक है 3,536 राहुल भी कर अभी क्या फिर सेटल कर देता समझ गया अंकल तूने मेरा 3600 रुपया कमीशन नहीं दिया इस बात का कमीशन सामने दिख नहीं रहा पुलिस स्टेशन की नई बिल्डिंग बन रही है कितने भी कारोबार है ना वो यहाँ पे आके खाना खाते मेरी नोटिस मैंने तुम्हें इतने कस्टमर दिए तो उसका कमीशन बनता है कि नहीं
तुम पुलिस वालों को खाना बहुत अच्छी तरह से आता है कम से कम एक्सरसाइज भी किया करो
मुझे भी तकलीफ हो रही है
या आसपास कोई और होते इसलिए कंस्ट्रक्शन वर्कर यहाँ आने का
मैं पुलिस वाला हूँ पुलिस सबको यहाँ पे आने के लिए रोक भी सकती
हेलो मार्टिन सर सर विजय राहुल साहब के लिए कॉपी अरे विजय क्या चल रहा है डील चल रही है सर अभी अभी कमीशन की इस चीज का कमीशन मैं पुलिस स्टेशन के कंस्ट्रक्शन वर्कर्स के थ्रू कौन ले रहा है कमीशन साहब सर खत्म हो गई बात ये पुलिस स्टेशन फ्रेंडली का क्या मतलब फिक्र ना होगी मदद करना ये तो पुलिस का फर्ज है तुम ठीक कर रहे हो जब तक पुलिस में लोग कंप्लेंट लेने से करता है कुछ नहीं इसीलिए तो हम ये सब कर रहे हैं लेकिन सब पुलिस वाले आप से नहीं कुछ बड़े बड़े मोटे काले चप्पलों की तरह होंगे जो सब स्वागत चूसता है
Let's get it. German luxury or Chinese. मैंने सपनों में 350 में इतनी ज्यादा हेलो दोस्तों मेरा नाम है छुट्टी का प्लान
И уже такие абсолютно понятны. Я здесь ищу только одного. Покоя, умиротворения, вот этой гармонии, от слияния с бесконечным вечным. Понимаешь, а ты мне опять со своими там это иди, суетись дальше. Это уже этот мир абсолютно понятен. Я здесь ищу. क्या है फॉरेन कुछ भी नहीं है फॉरेन में भाई अगर यही चीज हम अपने यहाँ बनाना चाहे ना वो भी बन सकता है बट थोड़ा सा सपोर्ट हमारी गवर्नमेंट का कुछ लोगों का भी बहुत इंपॉर्टेंट है क्यों क्या दिख रहा है यहाँ कुछ नहीं क्या है पेड़ पौधे तो हमारे यहाँ भी है सब यहीं पे है बिल्डिंग हमारे यहाँ भी है नदियाँ हमारे यहाँ भी है बस फर्क क्या पड़ता है साफ सफाई का यहाँ देखो कितनी साफ है सड़कें फूल दिख रहे हैं तो फूल ही है भाई गुटकों के सीधे हर जगह नहीं लगे हैं ये लाल है तो लाल है जहाँ पर किसी ने गुटका पैक के उसको लाल नहीं कर रखा लोगों ने सड़कें वहाँ पर तोड़ नहीं रखी देखो नदियों की बात करोगे तो तुम यहाँ पर किसी ने बॉटल से ही पैक रखी है यहाँ पर कुछ भी गंदा नहीं दिख रहा है जिसको तुम बोलो यही है और इसी को हम जैसे लोग पैसे देके देखते आते हैं 97.8 ग्रेड है 97.5
ये आईआईटी हो गया एम्स हो गया ये अच्छे इंस्टीट्यूट इसलिए नहीं है कि इनके पास प्रोफेसर बहुत अच्छे हैं इनके पास अच्छे बच्चे ही गए हैं आपने सेलेक्ट करके क्रीम को उठा लिया उसको पॉलिश मार दिया बासमती चावल उठा के पॉलिश मार दिया कहेंगे मेरा चावल सबसे अच्छा बासमती राजा राजा होता है चाहे सिंहासन पर बैठे चाहे जमीन पर बैठे जिस एंट्रेंस एग्जाम को लेके आप नीट ले रहे हैं क्या पाए लीजिएगा ना उतना ही पड़ेगा आईआईटी और नीट एम्स तो बहुत मतलब गुरु है उस चीज पे तो आप एक नॉर्मल इंजीनियरिंग कॉलेज या मेडिकल कॉलेज से प्राइवेट मेडिकल कॉलेज से बच्चे को उठाइए आप देखिए इसमें फर्स्ट हो जाएगा वहां पे तो आप क्या कर रहे हैं पॉलिसिंग कर रहे हैं कि आप क्रीम कलर के लिए उसको लगा रहे हैं आज वो 80% पॉपुलेशन होती है गवर्नमेंट स्कूल में है छत ये हमारा गवर्नमेंट स्कूल में गेट बंद रहता है हम लोग खुद के आगे भाग जाते थे कोई गांव के बच्चों को कहेगा ये ऐसे होते हैं जितने अभाव में वो झिंगा रहे हैं ना गांव के बच्चे शहर वाले जितना डिप्रेशन में सुसाइड कर लेते हैं ना उतना डिप्रेशन में स्कूल जाता है बचपन में
चाइना में आप अगर पब्लिक प्लेस में हैं कितना देखते चुके बहुत ही एंटीक इसका जो बनाने का जो ढंग है ना सर हाँ ये भी पता नहीं मेरा माइंड ब्लोइंग है यहाँ से इतना छोड़ा है और पेपर से इतना पतला पता नहीं बनाया है मेरे दादा ने कैसे ठीक है ये
नहीं है मौके तो इसमें फंगस नहीं आएगी, ठीक है। इसका ऊपर ऐसा ढक्कन ढक्कन के ऊपर हाथ रहता है, बस दो ये ऐसा ये फैक्ट्री वापस बाहर आएंगे। अभी अभी जमाने में घी कोई खाते ही नहीं थे, बाकी पहले एक बार में पाव पाव भर घी खा जाते थे। Janitor secretly stuffed a wad of paper into the water outlet while adding coffee grounds. When the boss was ready to drink his coffee, the coffee shot out and splashed all over him. The boss, helpless, decided to go to the restroom to clean up. At this point, one employee entered the blind spot of the surveillance camera and inserted a hairpin into the lock, completely jamming the door. Another employee then threw a bottle on the floor. Hearing the noise, the janitor began turning on the vacuum cleaner. Meanwhile, a man outside, hearing the sound of the vacuum, went around to the back of the building, connected a hose to a CO2 fire extinguisher, and then opened the valve. A large amount of CO2 started flowing through the hose into the restroom. Realizing something was wrong when he saw the gas, the boss tried to leave but found he couldn't turn the doorknob. His cries for help were drowned out by the sound of the vacuum cleaner outside. Gradually, the boss began to suffer from oxygen deprivation and eventually collapsed inside the restroom. After confirming enough time had passed, the man outside closed the valve and disconnected the hose. The security guard then destroyed all the evidence. The last employee pretended to go fetch water and, on the way, took the hairpin from the lock. Thus, a perfect crime was completed. At first, the police believed it was a slip and fall accident, and the surveillance footage showed no abnormalities. However, Nick noticed something was amiss. He saw that the restroom door handle had 2 scratch marks, indicating the boss had tried to open the door, but strangely, it never opened. Nick questioned all the employees, but found no suspicious behavior. It wasn't until he checked everyone's phones that he discovered all the employees had visited the same clinic. Clearly, this was no coincidence. In a rush, Nick visited the clinic, where a shocking truth was revealed during his conversation with the doctor. It turned out the company's employees had been experiencing various health issues. Some had severe hair loss, others had nails falling off, and some women had become infertile. To investigate further, the doctor asked the employees to bring in the company's food and water. After testing, it was found that they all contained a specific harmful substance. Unknowingly, the employees had consumed this dangerous substance. The company's boss had been researching new pharmaceuticals, and he was using the employees as guinea pigs for drug testing. He had placed the drugs in the company's bottled water, and by the time the employees noticed, it was already too late. Due to the excessive ingestion of these drugs, most of the employees were beyond treatment. This ailment would torment them for the rest of their lives. After hearing the doctor's explanation, Nick realized that the culprits were all the company's employees. But after thinking it over for a long time, he chose not to expose them. In the end, he classified the case as an accident.
क्या समय रैना यूके में इंडिया स्कॉट रेटिंग दोबारा शुरू कर रहे हैं एंड क्या यही समय रैना का बिजनेस कमबैक प्लान? चलिए डिकोड करते हैं। इंडिया स्कॉट रेटिंग के हर एपिसोड पर एवरेज 15 मिलियन व्यूज आ रहे थे, जो कि इंडिपेंडेंट आर्टिस्ट पुल कर रहा था समय रैना, एंड नेक्स्ट वो ये करने ही वाले थे। और जैसा कि समय रैना ने बोला, कोको कोला इंडिया स्कॉट रेटिंग को स्पॉन्सर करते हैं अपने जेंजी फोकस ब्रांड स्प्राइट के साथ। लेकिन इतना बड़ा ब्रांड किसी शो को स्पॉन्सर क्यों कर रहा है, ये देखकर ओटीटी प्लेटफॉर्म समय रैना को डॉग अमाउंट ऑफ मनी ऑफर करते हैं।
इस टाइम पर ओटीटी उतना पैसा फेंक रहा है मेरे मुंह पे, हर ओटीटी
और कुछ बेसिक कैलकुलेशन के अकॉर्डिंग ये डॉग अमाउंट ऑफ मनी काफी ज्यादा था। पता है कितने? 3 to 5 करोड़ पर एपिसोड ऑफ इंडिया स्कॉट रेटिंग। जिस हिसाब से जैसे कि ओटीटी प्लेटफॉर्म अमेज़न प्राइम, जियो हॉटस्टार, नेटफ्लिक्स ने 8 to 10 एपिसोड्स के एक सीजन के लिए अप्रॉक्स 30 करोड़ ऑफर किए होंगे, लेकिन समय इस ऑफर को रिजेक्ट करते हैं। एंड स्प्राइट के एपिसोड आने से पहले सुप्रीम कोर्ट का ऑर्डर आता है। फिलहाल तो इंडिया स्कॉट रेटिंग टिप्स के चैनल का कमबैक हो चुका। क्या समय
जैसे पहले तो पहली बात ये थी, सबसे पहले फोकस को कैश पर दीजिए, विषय चलान किसी संभाल के रखो। आप स्मार्ट जिस एरिया में चलान काटा गया है उसी जुडिशियल कोर्ट में मेंटेन करते हैं, ना कि जहां गाड़ी रजिस्टर्ड है। हरियाणा में अगर आप 2,50,000 के रुपए ले या अगर रोड एक्सीडेंट होता है तो फाइन 90% तक रिड्यूस हो सकता है। 10,000 का चलान सिर्फ 500 या मैक्स 1,000 में क्लियर हो जाता है। दिल्ली में 50% तक का डिस्काउंट मिलता है कोर्ट प्रोसेस के लिए। इसलिए कभी भी कराई मत लो, हमेशा जयपुर के एक सही जमाया है। बिहार में नौकरियां नहीं है और आप असिस्टेंट प्रोफेसर बन गए। हम 91 में एमए किए हैं, हम 2003 में पीएचडी किए हैं। हम इतनी बड़ी वैकेंसी तो हम नहीं कर सकते हैं। 58 साल की उम्र में पटना यूनिवर्सिटी में रजिस्टर रहते हुए आदमी हो गए असिस्टेंट प्रोफेसर। प्रोफेसर बनने का क्राइटेरिया क्या है? उसमें ग्रेजुएशन का मार्क्स चाहिए, उसका एक पेज है, उसमें नीट और जेआरएफ चाहिए, उसमें पीएचडी का पेपर का चाहिए, कितने आपने पेपर पब्लिश किए हैं, ये 4 5 महत्वपूर्ण चीजें। ये एडवर्टीजमेंट पहले का आया
बिहार में अगर आपको नेता बनना है, अब पैसा सुबह में लालू जी उगाड़ दीजिए, दोपहर में लालू जी उगाड़ दीजिए, रात में लालू जी, 3 टाइम तीन दवाई। लालू जी उगाड़े तो टीएमसी जी उगाड़े तो नेता बन जाओगे, सरकार चल रही। तो उदाहरण है, उनका पूछता होगा कि मैं एक नेता उगाड़ देकर बिहार में नेता बन गया, सरकार चलने के बाद कांग्रेस में, जब कांग्रेस की सरकार तो कांग्रेस में, लालू की सरकार तो लालू में, मांझी की सरकार तो मांझी में, नीतीश की सरकार तो नीतीश में, और वो कहता है कि सब चोर है, हम नहीं मरे। अरे जब सब चोर है, सब सब सरकार चोर था, तो उस सरकार का मंत्री भी चोर था, तुम्हारा बाप भी चोर है, और मेरा बाप चोर। बेटा दादाजी के पैर छूएगा।
क्या गजब का स्ट्रक्चर तैयार, इनके सारे प्लांट मट्टी से बने हुए हैं। ये वेस्ट चीजों को रिसाइकिल करते हैं, आसमान में से हवा पाइप के द्वारा जमीन पर उतारते हैं। इनके पास पत्थर की दीवारें हैं। क्या है गजब टेक्निक, चलो जानते हैं और देखते हैं इस कमाल की वीडियो।
So अभी आप मेरे पीछे देख रहे हैं, ये है 12 वॉशरूम जो कि हम लोगों ने एक फार्म हाउस के लिए डिजाइन करे हैं। टेराकोटा वैसे तो रिसाइक्लेबल है, मतलब रिन्यूएबल मटेरियल से बना है, मिट्टी से बना है, जो कि एक रिन्यूएबल रिसोर्स है। बट जब टेराकोटा बेक हो जाता है तो उसके बाद उसकी जो प्रॉपर्टीज है वो चेंज हो जाती है, वो सॉलिडिफाई हो जाता है, मिट्टी में वापस मिल नहीं सकता। तो हम लोगों ने सोचा कि अगर हम इतना ज्यादा टेराकोटा से ऑलरेडी एक्सपेरिमेंट कर रहे हैं, तो क्यों ना हम ये भी देखें कि टूट जाने के बाद। हमारे ऑफिस को ठंडा रखने के लिए हम लोगों ने कोई एसी का इस्तेमाल नहीं किया। हमारा ऑफिस नेचुरली कूल रहता है। पहली चीज तो हमारे कूलेंट सिस्टम्स हैं। फिर छत पे आप देख सकते हैं हमने थैच लगाया हुआ है। थैच नेचुरली जो है, जैसे आपने देखा होगा गाँव में या इस तरह की जगहों में छत पर रहता है, एंड उसके ऊपर पानी डालते हैं तो वो नेचुरली कूल रहती है। फिर इसी तरह से ब्लाइंड्स वगैरह जो होते हैं, जो बैम्बू के ब्लाइंड्स होते हैं, उनके ऊपर भी पानी डाल दो तो वो ठंडे रहते हैं। जैसे कि कूलर के पीछे जो खस होती है, तो यहाँ पर आप देख सकते हैं फ्लोर पर एक्सपोज ब्रिक है, यहाँ पीछे स्टोन है। तो एक्सपोज ब्रिक, एक्सपोज स्टोन, इन सब चीजों से थोड़ा ठंडा रहता है हमारा जो। और ये देख सकते हैं आप, ये जो दीवार है इसके अंदर सारे ओपनेबल पैनल्स हैं। अभी आप देख सकते हैं, अगर हम टेम्परेचर चेक करें तो बाहर का टेम्परेचर कुछ 46 47 डिग्री दिखा रहा है। अब हम इसको थोड़ी देर अंदर रखेंगे और फिर अंदर एक बार फर्क भी देख लेते हैं। अंदर आप देखिए इतने सारे लैपटॉप्स और पीसीज भी यूज हो रहे हैं। तो अभी आप देख सकते हैं अंदर का टेम्परेचर 22.3 डिग्री दिखा रहा है। एंड जब हम लोगों ने बाहर देखा था एकदम तेज धूप में रखा हुआ था, तब इसका टेम्परेचर था 46 47 डिग्री। जो ऑफिस है वो नोएडा।
ये देखने में तो ब्लैक बेबी पैंथर लगती है, लेकिन वन टाइम बेटर देन एवरीवन वाली वाइफ देती है। ये फीलिंग नहीं आएगी कि कुछ ऐसी लड़कियां जो सैंडविच को देख। दो अलग अलग जगह हैं, द्वारका दिल्ली के अंदर वही वही नई सिटी है, लेकिन दोनों में सनसेट रोड की बिल्डिंग दिख रही है, आग लगी 4,000 लोग
मना दो, आग लगेगी तब देखी जाएगी, जब आग लगती है तब ना निकलने का रास्ता होता है ना प्रोसीजर होता है।
वर्दी का रोग है ना, हमको मत दिखाना। मेरी माँ के लिए कुछ बोलना मत, जबान खींच के आग पे दे दूंगा तेरी। सुना मद्रासी अंग्रेजी पिक्चर हिंदी में छाप के बड़ा टाइगर बन के बैठा है साहब। ये आवाज तो अदर को छेड़े मारना साला। क्या माँ मेरी जगह चाहिए था, माँ होती है लेकिन इस साले को, इस लड़के को कूदे निकालने की जल्दी है, इसे मारने के लिए को। मैं बोला सर मुझे एक चांस दे दीजिए, एक चांस दे दीजिए एक्टिंग करने के लिए बस, लेकिन ये क्या बोलता है कि क्या बोला था तूने? क्या 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 आगे ये कैमरा है। हाँ क्या कैमरा, इसमें सब दिखाई देता है, तो बोल मैं क्या करने वाला हूँ। और नहीं तो निकाल तेरा कैमरा सर।
हाँ हेलो भैया। हाँ आ गए हो ना? ठीक है। बाहों में जाना, दिल मेरा घबराए,